Go.
Good morning, ladies and gentlemen, and welcome to the second day of Efecs 2020. We're very happy to welcome you back here. But for those of you who are only joining today, welcome to this event. We're very happy to have you as well. Well, I think for those that joined yesterday, I hope you had a very successful day, that you enjoyed the virtual booths and the different sessions that were planned. So before we start today, ladies and gentlemen, let me just run you through a couple of practicalities. Well, first of all, I think you need to know that this event will be recorded and afterwards also be displayed online for you to watch or perhaps to share with colleagues if you'd like. Also, you're more than welcome to engage with us online via Twitter by using the hashtag Efecs2020. And finally, and as I would say most importantly, we are looking for active engagement yet again. So please send in your questions. We're more than happy to take them on board. So ladies and gentlemen, today we are going green. And that's a wonderful color because the color of green stands for the Green Deal of the European Union. So that's something that we will be discussing today, but also something that you've heard a couple of times yesterday is the so-called SRIA, the Strategic Research and Innovation Agenda of the electronic components and systems industry. And we will start with presenting to you parts of this SRIA, and for that we have three outstanding speakers that can tell you a little bit more about that. So the first speaker I'd like to announce is Elisabeth Steinmetz, and she is the Office Director of EPoSS, and for more than 20 years she was active in the field of compound semiconductors, and since 2019 she serves then as the Office Director at EPoSS. In this position she was chairperson for the update of the ECS SRIA, and for this year's Majors Update 2021. And she will talk about the structure, the history of the SRIA. So I would say, Elisabeth, the floor is yours.
Thank you very much, Charlotte. And I'm looking forward to present the ECS SRIA 2021 to you. I hope you can see my screen now.
Yes, we can.
So last week we published a brand new version, a major update of our SRIA, and together with the co-chairs Patrick Coget and Patrick Piep today to present what we did and what we achieved. So looking back at the history and the purpose of this document, I would like to state, well, first of all, this is a document that is driven by the three industry associations, AENEAS, ARTEMIS and EPoSS. Being active in this field of electronic components and systems and representing a big part of the industry in this field. So we teamed up in 2014 in the creation of the ECSEL Joint Undertaking, and in that time we had three separate SRAs. In 2017 we came up with the first common SRA, but at that time still you could distinguish between the different areas and the different fields and where the origin of the writers came from. I think what we have achieved now after, again, another loop is that we really have a common view and a common document that we are going to present to you today. So what is new in it? Well, first of all, you might recognize that it is now called SRIA. This has to do with the case that, of course, what we are doing here is not only a research agenda, but really an innovation agenda. We are representing the industry and the innovations that have to be done. So, and we are covering a horizon of 10 years and above here, but of course, the predictions are better in the short term. So this document is funding agnostic. It is not written for KDT. It is really the document of our industry representing what we want to achieve in the next years. And nevertheless, of course, it serves as a basis for us for the SRIA of the KDT. And so, as I said already, it served as a basis for ECSEL, and it will hopefully serve as the basis for the KDT up to 2030. And but this is not all. It is also our SRA for the EUREKA clusters, as Peter Connock stated yesterday already. So Penta and EPoSS are building on this SRA as well. And hopefully also successor EUREKA clusters to come in the next year. So the whole thing has been a real great team effort. those of you who participated in the ECS brokerage event in January might recall that at that time we had our kickoff. We presented the SRA from the last year, and in a poll we asked the people who contributed to it, and only 20% said that they did. Afterwards, after the presentation, 79% said that they are willing to contribute to the next one. And so I think this, now having a look back after 11 months, who actually contributed, I think this has all been fulfilled. So thanks to all of you for your big contributions to this. So we have been working in a core team with 12 people. We had 53 chapter leaders, section leaders being very active and collecting the information in the different fields and being really experts in these fields. And we had totally 299 contributors so far. But I have to say that the document is open now. So we have published it last week and you can still contribute to it. So it's open until December 14th, so please have a look at it. And to even make it more interesting for you to look at it, I would like to show briefly what is new in it. Well, I think first of all, the most striking thing is that we have a completely new structure. And this is introduced in chapter 0, so you and I will introduce it to you in a minute. And what we have achieved, I think this is also one of the highlights, is we have analyzed all the major challenges that we have in the document. And out of that, we have derived with, I think, a great input and a great idea from Paolo Azzoni, great thanks to him, these 4 main objectives that will be presented by Patrick Peep later. And, but that is not all. Based on these main objectives, we have created global timelines, short-term, mid-term, long-term, and we have broadened our scope. So because we see that our industry is moving and that new topics come in. So we have encouraged people from the integrated photonics and the flexible electronics community to take part in this process and to give their contribution to the document as well. And I think what is also worth noting is that we have now a glossary at the end of the document in the appendix, which really describes what we mean when we talk about a device, a component, a system, because we recognize that even in our community, we have a different view of what a device or what a component actually is. So, and then last but not least, I think what is this is a teaser for another document. We have created an executive summary, and this executive summary will be published soon. So it is addressing and entitled Markets, Objectives, Challenges and Required Achievements for the European Digital Age. So this is a quite impressive title, I think. And in that, in this document, we are describing what our industry is thinking, what is required for the future. But we synopsis of the ECS SRIA in it. So it serves the purpose of being a document for decision makers. So coming back to the bottom-up ECS SRA and to our new structure, I think what is really a big change is that this time we started really with the technology layers. We started with foundational topics from process technologies over components, modules, system integration to embedded software, and this time, and this is new, to systems of systems. So we go one layer higher than we did in former SRAs, because we believe that the connection of system is another very important task that we have to cover. And as you have seen yesterday in the presentations and the discussions, that these are not the only technologies that we have to focus on. We really need cross-sectional technologies to be competitive in the future. And the cross-sectional technologies here shown in these vertical columns, they really go through these foundational technology layers. And so we have a whole chapter on artificial intelligence and edge computing, which is one of the key topics and the key things we have to address in the upcoming years. We have a whole section on connectivity, on 5G, 6G, but we also have these cross-cutting things that are necessary to make the whole thing work, like architecture and design methods and tools, because for the autonomy of Europe, it will be of utmost importance that we are capable of designing our own structures. And last but not least, quality, reliability, safety, and cybersecurity will be key topics for the sovereignty of Europe. And these are what we call the technology chapters. They have a specific technology-oriented structure. But of course, we are reaching out to a lot of different applications. And so we are describing the key application areas in Chapter 3. Again, of course, the main application fields for Europe are trust here, the mobility, energy, digital industry, health, and well-being. And we have a brand new chapter on agri-food and natural resources. Of course, also directing into the green. And we have a chapter on digital society. And this connects very well to the motto of this Efecs, technology working for people. So this is really in the focus of what people need. So this is with these words, I would like to hand over to my colleague Patrick Piep, because I think it's quite boring to listen just to one person, and we are a team of 3. So Patrick, please, could you move on and explain to us the new challenges that we are taking up here in our S3?
I'm still on mute. So do you see my screen?
Yes, we do see your screen.
Okay, so thank you, Elisabeth. So in fact, I would like to briefly talk about the EU challenges or the EU main objectives taken up by the SRIA. Compared to the previous version, in fact, the main difference is that we really have been looking at how are these EU challenges as a common thread or fil rouge throughout the SRIA. Because in the past, the previous document was really written bottom-up from the research community. Now we have also been looking top-down on how the European challenges fit into the SRA. So the first challenge we see is how to boost the industrial competitiveness in technical innovations. The second one is the topic about European sovereignty, how to achieve European sovereignty in a number of key applications domains. The third topic is the topic of today's conference day, and that's about the Green Deal and how to establish and strengthen a sustainable and resilient ECS value chain supporting the Green Deal. The last challenge is to unleash the full potential of intelligent and autonomous ECS-based systems for the European digital age. So what we have been doing is we have been looking at the different chapters in the SRIA, and we have been looking how do they contribute to the 4 major challenges. So at the top you see again these 4 major challenges, and below you see all the sections and all the chapters of the SRIA who are relevant to these 4 main challenges. Of course, this slide is hard to read, I fully understand, so that's why I've taken an example. For example, if we look at the challenge of the Green Deal, how it contributes to 3 of the chapters in the SRIA. It contributes to, of course, all chapters, but I just give an example here how it contributes, for example, to the application area of mobility, industry, and health. So you see in mobility, 3 out of the 5 chapters are related also to the Green Deal. Electrification and sustainable alternative fuels, safe and environmentally neutral light mobility, and affordable, automated and connected mobility. And all the topics we are covering are really aiming at the targets of reducing CO2 reduction by 37.5% in 2030 compared to 2021, and evolving to a zero net emission in 2050. We have the same for industry. 2 of the challenges there are responsive and smart production and sustainable production, which also contribute to the Green Deal. And also for health, we have 5 topics which are oriented to contributing to this Green Deal. We also have a timeline. So for each of these 4 challenges, we have defined a number of milestones or main checkpoints, as we call it, what we can realize as an industry, working together with research institutes and universities throughout Europe in the time frame as indicated on the slide. And in order to give some more explanation on this timeline and how this is really implemented in detail in the SRIA, I would like to give the floor to Patrick Auger.
Thank you. Can you see my screen? Oh, you don't see the, let's see, the right one, I'm afraid. Yeah, I hope.
Yes, yes, we
right
can see your screen. Thank you.
Okay. So thank you, Patrick, and good morning, ladies and gentlemen. So you might be surprised to see the drawing of an ancient wise man, Lao Tzu, appearing in the middle of the presentation of a European research and innovation agenda. Well, this is actually not to recall our discussions yesterday on European digital economy in front of rather formidable competition from other regions of the world, but in fact, it is also because Lao Tzu is usually credited to have authored the Tao Te Ching, which contains a famous saying, "A journey of 1,000 miles begins with a single step." And the link with the strategic research and innovation agenda is that on top of defining ambitious goals at an horizon of 15 years, we need to describe more precisely the journey to get there, step by step. And this is why the SRIA includes not only research topics to be investigated, but milestones to be reached in specific time period. Well, those timelines were already present in different domain chapters in the previous editions of the agenda, but what is new this year is that we have attempted to summarize them at the global level to provide more of an helicopter view of the ECS roadmap. So in the introduction chapter, you will therefore find 3 timelines, each corresponding to a specific time period. So short term, where the industry has a precise idea of what must be achieved. Medium term, where the knowledge is not so precise, but still reasonably good. And finally, long term, so 2031 and beyond, where the expected achievements are more of a prospective nature. And listing a milestone in a time period means that it is expected to be then available as prototype in early commercialization. And this is how these timelines look like with the example of the short-term one. So I'm obviously not expecting you to be able to read this example in details, but this is just to explain how they are structured. And you will find the 14 sections presented earlier by Elizabeth grouped along the 3 chapters: foundational technology, cross-sectional technology, and key application areas. And what we did is that we tried to identify for each section the most salient milestones. So this is not an exhaustive list, and more milestones are actually listed in the individual sections. Nevertheless, it conveys how the sections and their individual roadmaps are linked between each other. For example, materials enabling recycling and repair, or even biodegradable materials are identified by the section components, module, and system integration, and they will enable the widespread deployment of sensors to monitor forests, fields, and ocean, which is expected by the section agri-food and natural resources. And those sensors will benefit from the availability of solutions for advanced artificial intelligence at the edge, as proposed by the section on artificial intelligence, edge computing, and advanced control. So this example shows that the SRIA is really an instrument to promote synergies. First of all, synergies within the various domains of competence of our community, as we've just seen, with technology advances enabling new breakthroughs in application, and vice versa, application sections translating application level roadmaps into ECS technology requirements. But also synergies between the ECS community and adjacent communities, of which we can cite a few. For example, the proposed European Partnership of Connected Cooperative and Automated Mobility has close links with the team which elaborated the mobility section of our Srq. The European Factory of the Future Research Association is tightly coupled to the Digital Industry Section team, the Big Data Value Associations, and many others. And finally, we also have synergies with our colleagues beyond the European borders, since many of the experts who elaborated this Srq are also active in worldwide initiatives such as the International Roadmap for Devices and Systems, or the Heterogeneous Integration Roadmap. So we really, really hope and believe that this collective effort is an instrument for innovation, because innovation often comes from making different viewpoints and knowledge sources come and work together. And with the floor to our chairwoman, Elisabeth, for the final words of this Srq presentation.
Thank you, Patrick, and thank you all for your kind attention this morning. As I stated already, the Srq that we published is a draft version, and so it is open for your feedback and your contribution until December 14th. And you can reach us through the email address given here, but also contact whoever is in the team, and we will receive your feedback. So thank you very much for your attention, and I will hand over then to the moderator again. Thank you very much.
Thank you so much, Elisabeth and Patrick Pieper and Patrick Coget, for your kind contributions. And I must say, indeed, you have put a lot of thought into the Srq, and it's also good to see that you already involved a lot of actors since the beginning, but that you're still collecting feedback to make the agenda even better. So once again, ladies and gentlemen, you can provide your feedback at the email address as stated by Elisabeth, but you're also more than welcome to come up with your questions, your ideas and inputs during this session. So ladies and gentlemen, we now have a very good overview of what the Srq is about. We have a very well-defined timeline. We know which kind of topics have been integrated in the agenda, and also we know what the key objectives are of the Srq. And now we also would like to have three people to give them the floor to tell a little bit more also their perspective. And I'd like to start first with Paco Ibanez, and he's the Deputy Head of Unit for Competitive Electronics Industry at DG Connect. It's a great pleasure, I must say, Paco, to have you again today. And I know you had to excuse, unfortunately, your head, Colette Maloney, who couldn't attend, but we're very, very happy to have you. So I'd like to hand over the floor to you. So, Paco, can you hear me? Paco? Just checking if he's there. Because I can hear quite some noise in the background. Okay, if Paco cannot hear me right now, then I suggest that we switch to Stefan Mengele, so we can keep the sequence going. So we'll do it like that. So Stefan. Introduction to Stefan Mengele. He's the head of the division at the German Federal Ministry for Research, and together with his team, he's responsible for research programs in microelectronics, autonomous driving, and
sound. I wonder if you can hear me.
Yes.
So I can go ahead. Okay.
Okay.
Thank
okay.
you.
So Paco, just
okay. Just for information,
second.
I have no sound, so I'm talking in full silence here. So good morning, everybody. I hope you are ready for a new day on Efecs for the second day. So we have been listening with interest, and we actually have received a draft of the Electronic Component and System Study Research Innovation Agenda. This is a document that we really appreciate the effort which is behind. It clearly has the richness of having multiple views integrated into something we consider really a reference document. We believe this is a very strong basis for the putting in place for launching the new partnership on key digital technologies. We certainly don't expect that this exercise will be repeated, certainly at the intensity that we had done this year. But of course, we will be willing to work together with you towards revision to make sure that this document, through the lifetime of the partnership, the 7 years that we have ahead, really reflects the priorities of the industry, the priorities of the society, and the political lines that we in Europe and at the national and regional level has been put forward. So again, what we really appreciate additionally this year is the effort you have made into identify out of this long and detailed document a number of lines, priority lines, on which we can join effort. This is very important. I think clearly, as presented by Elizabeth and colleagues, this document reflects the full view of the sector. So it's intending really to be an encompassing document, an encompassing view of how the situation is today and how we expect to be evolving in the future. So what we would like to work with you from the Commission, but also from the Member State side of the partnership, to make sure that the alignment between the priorities that you have been putting forward in this high-level summary and the priorities that we, from the political side, are trying to, again, support are fully in line. So, as I said, we have time now in this initial part of the partnership to sit together, to discuss, to agree, and to make sure that we have we call a strategic impact by focusing effort around specific lines of research and innovation. Thank you. And thanks all colleagues for the effort you have put in drafting and creating this very rich and very important reference document.
Thank you, Paco, for your contributions, and apologies, ladies and gentlemen, for this small hiccup. But I think Paco has been really clear in his presentation that he said the SRIA really reflects the full view of the sector, which is, I think, a good thing. And of course, he's also seeking some additional strategic input if you have any, and we're happy to take that on board. So, ladies and gentlemen, next speaker up, and I was already partly introducing him, but let me start again, is Stefan Mengele, and he's the head of division at the Germany's Federal Ministry for Education and Research. And together with his team, he is responsible for research programs in microelectronics, autonomous driving, and supercomputing, and he holds a doctoral degree in experimental particle physics. And Stefan, we're really happy to have you. I think we already got a very nice overview by your State Secretary, Mr. Lucas, who already warm-heartedly said, we believe in this community, which can really make a difference. So having said that, we're really happy to have you, and we're looking forward to your presentation. Happy to have you. Okay, he can't hear.
Am I heard?
Yes.
Very good. So very good. Yeah, thank you. Thank you very much for the invitation and introduction. And yes, indeed, I was also happy that my Secretary of State yesterday gave an enthusiastic speech on ECS and microelectronics. And indeed, as he pointed out, he started his career in the BMBF, in the Federal Research Ministry, say more than 25 years ago. And at that time, lithography was one of the issues we dealt with, and among them it was already the time where the EUV technology was discussed. And so, as you know, EUV is getting into the market. EUV technology is flourishing, but it took more than 20 years in R&D to prepare that situation we face today. and this is what fits to what was said by Elizabeth before. We need to have a long view, long-term, we need to prepare ourselves for a long-term endeavor. R&D needs also to tackle long-term goals and issues, and EUV shows to us that this is awarding, and this is something which we should follow on also in other fields. So coming to green ICT, to Green Deal issues. So, and the next slide, please. And so everybody knows that efficiency, energy saving is part of microelectronics and ECS ever since. So this is nothing new. And everybody knows that ECS technologies are instrumental to help in other sectors to save resources, to save energy, to reduce the CO2 emissions. For instance, in mobility and energy, wherever you like. So this is also not new. But what is new today is that the ECT, the ICT sector, the digitalization itself becomes a part of the problem. Could you display the next slide, please? Am I still heard?
Yes, you're still heard. Loud and clear.
Very good. So what I'm trying to say is that the ECS technology, the digitalization itself, covers a significant share of the energy consumption on the global scale, and it stands for a significant share of the CO2 emissions. So could you please go back in the slides? So the second slide, please. So already 3.7% of the global CO2 emissions in 2019 originates from digital equipment. And the forecast says that this will rise until 9% in the next years. So we are facing a situation where the ECS technology, or the ICT itself, the information and communication technologies, will be regarded or will be perceived as part of the problem and less part of the solution. And this is something we should work on. We should do something about it, because we need to prepare ourselves that the role of the ICT is not to be part of the problem. The role should be what can we do to make ECS, to make ICT technologies a part of the solution, as it was ever since, and that's my message. What we did first on the national scale, as mentioned already yesterday, Germany published its new program on electronics research, and the new program, as you see here, has two major, strands to follow. The headline is trustworthy and sustainable. Sustainable means we want to make electronics a significant part of the solution for dealing with the climate change, for doing something against ever increasing CO2 emissions. That's our point. We need to point out that ECS is part of the solution. And to do that, we need, and that's my message, we need first to clearly show what are the contributions, not only in quality. Of course, it is accepted that with smarter solutions, you can drive down the energy consumption, say in electricity grids or in other infrastructure organizations. That's accepted, but we need to work on to make that really clear in terms of numbers. What is the quantitative contribution of a specific ECS solution in terms of CO2 reduction, in terms of energy savings? We need to point out which technology we want to develop to do that. And now please show the next slide. We think and it was mentioned already, but we think that edge computing is not just another approach when it comes to, say, what's between cloud computing and traditional solutions. Edge computing is also a contribution to bring down the energy consumption in the data-driven environments. But we need to work on to make that in a way measurable. We need to work on clear figures and use cases. We need to work on clear relationships between how much CO2 reduction is achieved by what type of technology. That's important. Power electronics, of course, is important. Power electronics paved the way to electromobility. This is known and accepted. But the quantitative contribution is less accepted or less clear, and this is something we need to improve. And that's my final point. We need to distinguish between ICT for green and green ICT. So ICT for green is almost accepted, it's established. We use ICT technologies to improve energy consumption in other sectors. But the innovation lies in the other sector. Green ICT, on the other hand, is to reduce the energy consumption by ICT technologies themselves. This is something we need to work on, and my recommendation also for KDT is to distinguish between both strands in order to make clear on what we are working on and what falls in the responsibility of other sectors, what is driven by research and what is driven by regulation. Green ICT is driven by research, and CO2 reductions in other sectors enabled by ICT is driven also by regulation, is driven by market forces and other things. And this is my recommendation. We should make that as clear as possible to indicate what is the contribution of the ECS community. Thank you very much.
Mr. Mengele, for your contribution as well, and for pointing out to us the distinction there is between ICT for green and green ICT, and I'm sure we can also focus on that later on during the panel discussion. So once again, thanks a lot for this. The next speaker I'd like to introduce to you is Michael Valk, and he's the Managing Director of the European Research Programs at the Austrian Research Promotion Agency, FFG. And as a EUREKA NPC, so a national project coordinator, he's coordinating the life cycle of international R&D projects. In additional roles, he worked as consultant for R&D projects and technical reviewer with a long history in ICT. So he knows very well what he's talking about. And I'd like to say, Mr. Valk, the floor is yours. Mr. Valk, the floor is yours.
Thank you very much for the introduction. Very kind of you. I hope you can hear me well and see the slides.
Yes, we can. Thank you.
Perfect. So the Austrian and EUREKA position and programs on the Green Deal. I would like to start with an example in the spirit of the bottom-up approach of EUREKA. Here you can see on the right, you can see one of the EUREKA projects. It's a project to cool down buildings using some kind of panels that have plants in it. Hopefully you can see here the relation to the Green Deal very clearly, and it's obvious. But there is also a relation to electronic components and systems in these projects, because behind these panels there is a fully automated and intelligent control system using sensors to measure the soil, plants, and the environment, to model microclimate and to evaluate ecological conditions, and also to monitor the air and material behind these panels, because you don't want them to fall down or want the plants to fall down. They measure the heat flux and building properties, so they are really smart panels using some natural resources. And there is a simulation tool to optimize the plant selection and the development and reduce maintenance costs. So this is a typical EUREKA project, like it's developed during the Austrian chairmanship and like it's developed in the 35 years of EUREKA until now. So what EUREKA is a family of instruments, of R&D instruments. Behind them is some kind of funding model, often distributed to the national funding bodies. This family has 4 instruments in it. So these are the EUREKA cluster projects, the network projects, the Eurostar projects, and the Global Stars projects. And all of these instruments progress to make some contributions to the Green Deal. And I would like to give some additional information on all of these instruments, very briefly only, as an overview. So the EUREKA cluster models, they are currently revitalized. So there is a new EUREKA cluster model. They allow for more flexible cross-cluster calls across all clusters. And there is one specialized cluster on low carbon energy that focuses only in this direction, EUREKA. The evaluation for Eurostars 3, which is currently in planning, will consider the environmental impact to a greater degree, and the global outreach of the EUREKA network and Global Stars projects will further consider through the national priorities, because these are nationally evaluated, will consider objectives of the Green Deal. So some more information on this. So this is really just an excerpt of what is happening. There is a planned 2021 EUREKA cross-cluster call on technology-powered green transition. Now what is special here is that this call looks at the sustainable development goals and tries to derive topics for this call. So really, this is a call where all EUREKA or a lot of EUREKA clusters participate, and it is thematically focused on making progress on the sustainability development goals. One of the clusters that participates is EUREKA, which I previously mentioned, that has a strong focus on Green Deal objectives like decarbonization, decentralization and digitalization, and deregulation and democratization. So this was about the EUREKA clusters. Then EUREKA Eurostars. Currently the Eurostars 3 is in the planning phase. So there is a proposal for Eurostars 3 at the moment. And in this proposal, we can already see that the evaluation criteria will look at projects, and the projects of high quality and high impact will have to include some societal and environmental impact descriptions. And at the same time, the reporting about all these Eurostars 3 projects will include data from the Sustainable Development Goals and the European policy around the Green Deal. So this was the contributions of EUREKA Eurostars to the Green Deal objectives. And then there is the interesting case of the EUREKA network and Global Stars, which are funding instruments that are distributed public-private partnership. That means that the national agencies perform the evaluation and provide funding. So here I can talk a little bit more about the Austrian contributions to the Green Deal, because we evaluate EUREKA network projects in Austria, and our national evaluation criteria take into account the various dimensions of sustainability. So we take into consideration the environmental impact, climate protection, resource consumption, responsible consumption and production patterns, energy consumption, health, sustainable industry, and clean mobility. And we take into account if the projects provide benefits for society. And this is, by the way, how the success story from the beginning came to be. This was evaluated also in Austria. So some more information about the contributions of Austria to the Green Deal. If there are any listeners from Austria, this might be especially interesting, but I would assume that in other countries we have similar situations. So if we take Horizon 2020 as a benchmark, we can see here on the right side that about 40% of projects in Austria, Horizon 2020 projects in Austria, have some contributions that can be linked to the Green Deal. But we can see on the far right that a greater percentage of projects is funded nationally in Austria. So we have a really strong focus on the Green Deal. And statistically speaking, if you have a relation to the Green Deal, you have good chances to actually receive funding based on this statistic. We find in this data then some additional focus points on mobility, zero pollution, and industry. And we find also partners, international partners like Croatia, Slovenia, Latvia. And with these countries, the projects usually have a high relation to the Green Deal. And we find that all kinds of organizations, universities, research institutions, and companies are involved in these projects. Now, to reach the top of this abstraction, starting from the success story and the instruments towards a more abstract level, we can reflect on the situation in Europe, I think, by looking at other regions. And for example, we can look at how they interpret the Sustainable Development Goals in Japan and what kind of necessary contributions they identified. And they want to bring about the so-called Society 5.0, and they identified this Moonshot research program, which is quite interesting. And here we can see two goals. Goal number 4, the creation of the industry that enables sustainable global food supply by exploiting unused biological resources. And the Moonshot goal number 5, the realization of sustainable resource circulation to recover the global environment. And on the left, we can see some illustration with some topics, total control of soil and optimal use of biological resources, and a much extended cycle for recycling. Of course, Japan is just an example where we can find some correlations between European countries and other regions, and if we can identify these correlations, we can facilitate global progress on sustainability. And this is also just a reminder that EUREKA is a growing global network that is expanding, and we are looking for new partners and actively engage with new partners worldwide. And so a short summary of what I think are the conclusions. On 3 levels. On the project level, we can say that applicants for R&D projects can increasingly focus on including the Green Deal objectives, because statistically these projects are more likely to receive funding, at least in Austria. But again, I would assume in other countries there would be a similar progress. On the instrument and call level, we hope that agencies implement the objectives of the Green Deal, because we see that there is a demand from companies, from society, and from organizations. So we have to provide the tools for these organizations. And on a policy level, we really have to enable this kind of global change, and we have to break down barriers, and we have to enable the previous 2 points. Because a global development is not possible without considering also the policy level. So thank you very much. I give back to the
Mr. Valk, also for your presentation and for outlining to us also the opportunities within specifically EUREKA, but also on the national level on how you would like to contribute to the Green Deal objectives. And I'm sure also with Austria being the chair of EUREKA at this very moment, you can give an extra push forward. So thanks a lot for that. So ladies and gentlemen, we'll now have a small Q&A also with the speakers that you've just heard. A question that already popped up is like, where can we find this draft strategic research and innovation agenda? well, ladies and gentlemen, you can find them on the websites of ARTEMIS, of AENEAS and EPoSS. So you're more than welcome to have a look at that. And perhaps what I'd like to do as well is to take some other questions on board that came in. Perhaps a question to Mr. Mengele, but also Elizabeth, regarding the terms of ICT for green or green ICT. This person says, okay, I can't really find those terms in the Srq document. How would you plan to match this together? Will you still do that so that there's really a complementarity between the national level plans in Germany and the Srq, the all-over level at European level? So could you comment on that, Stefan and Elizabeth?
So maybe I start, because I can't see Stefan Mengele at the moment.
Yes, please.
Yes, so it is in the Srq, but it's maybe not named in the same way. I think it's a bit the problem that, like we had it with the glossary, terms pop up and are created, and what we do in the document is more bottom-up, describing technology developments that we are facing and that we see that are important. But the whole chapter on edge computing is about, of course, reducing the energy. So this is, from my point of view, the biggest part of green ICT. So if you take and this is also in the technology chapters in the 1.1 and 1.2, and through the whole document, or we talk about reducing energy, and I think this is the main goal for us to become greener at the end. And of course, we have also covered the ICT for the green, because all the application areas that we are covering, especially topics like energy or agri-food, natural resources, they are addressing these challenges. So it's not that it is not in; it's maybe not named the same way. So we can improve, and we have to improve on that, and we have to somehow also find the right wording to make clear.
Yeah, I think this is very helpful, Elizabeth, and very clarifying indeed. Perhaps Mr. Mengele, you would like to comment on this from your side?
Yes, thank you. So just to explain from where I'm coming from. So we introduced electronics into our national climate protection program. And in that arena, it was heavily discussed which measure contributes to which level to CO2 reduction. It was not enough to say there is a quantitative evidence that electronics or ECS is contributing. That was accepted. But we need to go further to make clear what is the specific contribution. And having said that, we need to detail out what is to be done on the, say, on the electronic side, and on the side where electronics is applied or deployed. So the discussion which lies ahead of us, who does what in terms of specific CO2 reduction, needs to be as much, much more, say, clearance, to be much more on which strands we are working on.
Yeah. So, Mr. Mengele, I think there was no doubt at all about the valuable contribution. It's more about the terminology that can be used so that people understand, okay, when I look at the Srq, this is also about ICT for green and green ICT on the one hand, and that also the people that from Germany, for example, that when they read the Srq, that they see a kind of like a connection between the two documents. Indeed, yeah.
Okay, fine. So what's in the Srq is fine as far as I know it. I haven't the full overview, but what was shown and what I've seen is fine. And it's important to point out that we have both ambitions. But after all, we should concentrate on innovations in the ECS sector. Innovations in other sectors are important as well, but they should lie in the responsibility of the other sectors. And this is something which should be made clear. In other words, we should practice what we preach. You know, we should really concentrate on ECS, making ECS greener instead of doing everything else.
And I think that is very clear in both agendas. So the audience, I would definitely like to ask you to have a look at both documents at the SRIA, but also the document on electronics research for 2021-2024 by the German Federal Ministry. So thanks for that. Then one final question I'd like to ask perhaps to Patrick Pieper. How flexible is the SRIA? And the reason why I'm asking, of course, now all of a sudden, since this year, we're facing a crisis. To be flexible, you have a very long-term agenda, I would say, and I think we cannot exclude a thought on perhaps having another crisis within now and 10 years' time. So how flexible is your agenda?
Well, I think this agenda is quite flexible. First of all, we have the short-term ambitions, and these are really oriented to what lives in today's society. Of course, nobody could have predicted what happened with the COVID, but if you look to the previous version of the agenda, there were a lot of activities which could already lead to solutions to COVID, because from a technology perspective and of course from an application perspective, we should be flexible. We do an update every year of the SRIA, so we take into account all new things happening in society in the year, and then we adapt the SRIA as is.
Perfect. Thanks a lot for that. Ladies and gentlemen, unfortunately, we do not have more time for this specific panel discussion. So thank you so much, Elizabeth, and both the Patricks for joining us and for having outlined the agenda. And good luck with this agenda. And I'm sure you will do really, really well because you already have a lot of buy-in from the community. Valk and Paco Ibanez back later on during a broader panel discussion. But before we do that, of course, we also would like to hear from the project side. Projects are being informed also by policy decision-making processes, and we're really happy to have 3 people on board that can tell us a little bit more about their contribution to the Green Deal objectives. So what we have asked them to do is to first focus on the outline of the project, secondly on their contribution to the Green Deal objectives, and thirdly on the importance of European research development and innovation collaboration. And the first person I'd like to introduce to you is François Brunier from Soitec, and he's been there since 2002, and he's been a partnership program director since 2012. And Soitec is a company which designs and produces innovative semiconductor materials for manufacturers of electronic components. And in his role, Mr. Brunier has been a coordinator of many programs, such as the ENEAS pilot line Agathe, but also been part of a couple of research and innovation actions and innovation actions of ECSEL, such as Reference, Ocean 12 and Beyond 5. I don't think I need to say more. Mr. Brunier, the floor is yours. Mr. Brunier, the floor is yours.
Thank you very much, Charlotte, and good morning, ladies and gentlemen. It is an honor today to represent the ECSEL Ocean 12 Consortium for this Green Deal panel. So let's start with the beginning and from the Green Deal. The Green Deal targets no net emission by 2050, and as Stefan Mengele says, it relies really strongly on the digitalization. But if our industry brings a smart solution to the Green Deal, it is also part of the problem. And you can see here that with increased connectivity trend, the amount of data transmitted and stored into the cloud is exploding. Cloud computing is today a costly and energy-hungry process, and by 2040, the total computing power per year is expected to reach 100% of the world energy production. A sustainable path, and this is where new solutions like the AGI and low energy consumption technology come into play to bend this curve. I would like to insist really on the critical importance of the AGI, which will be the epicenter of innovation over the next decade. There are 2 main axes for this innovation. First one, smart dedicated sensors with a primary concern on power consumption, and for these, our industry has to develop disruptive technologies able to reach up to 0 power. And the second axis is smart devices like watches, smartphones, supporting multiple functions with several sensors. And in this case, the balance between computing and power efficiency, in other words, the number of teraops per watt becomes the key metrics. And for this, our industry must supply robust and energy-efficient technologies with the right digital performance. FD-SOI, as you can see here, has already started to power this edge computing revolution. For AGI, FD-SOI actually is the technology that checks all the boxes with the right features: digital performance, great RF connectivity, digital mixed signal integration, higher reliability, presence of embedded memory, low manufacturing costs, as it is a planar technology, and of course, extremely low power capabilities with the adapted body bias IPs. And in Ocean 12, we believe that this European technology platform has a key role to play in the edge computing era. And not only we believe, but we demonstrate it. Mid-2018 and gathers 30 partners from 8 countries along the complete value chain. It starts from the substrates and technology with Soitec, ST, and Global Foundries, going through the designers with Dolphin. It goes up to the OEM and system level, and it creates a real ecosystem of SMEs and universities around the FD-SOI technology. It is centered, the project, on the state-of-the-art pilot line, enabling 18 and 12 nanometer FD-SOI technology. And it demonstrates the advantage of this technology in key application sectors. And you can see the partners will develop neural network accelerator, massive parallel processor arrays, and automotive radars and wake-up system on the other side. All of these are based on the FD-SOI with a common point of high energy efficiency. With that, I would like to conclude showing you one of the main outcomes in terms of impact of the project. This is this 22 FD-SOI CMOS automotive radar, a demonstrator that is led by Bosch. Thank you.
Thank you very much, Mr. Brignier, for your very clear presentation, and definitely you managed to outline well your ambitions and also your added value to the Green Deal objectives. The next speaker I'd like to introduce to you is Anja Majstorovic, and she is the Head of Development of Easy Innovation, and this is a company in which she leads 3 different teams, one on R&D, one on AI, and one on web development. She's responsible for research, for planning, and implementing new programs and protocols in the organization and coordination of the development of new products in the field of IoT for smart home, smart health and safety, and security applications. Her responsibilities in funding projects are to lead technical R&D activities and coordinate work together with industrial and research project partners. Ms. Majstorovic, I'd like to give the floor to you. I'd like to give the floor to you. And you're still on mute. Could you unmute yourself, please? Okay, let us see if this will work. Ms. Majstorovic, can you unmute yourself?
Yeah, can you hear me?
Yes, now we can hear you. Thanks a lot.
Can you see my slides as well?
No, we can just see the screen with all the other participants. So if you could share the slide, we just saw it.
In just a moment, let me try to do it.
Yeah.
Now?
Almost. Yes, there it is. Thank you.
Thank you very much, everyone, and thank you for inviting us here. Actually, we are very honored to participate. I will introduce you Srq Project, what stands for Environmental Sensors for Air Quality. So Srq Project is within the EUREKA Penta cluster. It's managed by Industry Association AENEAS. And we are aiming to delivering selective, sensitive, and reliable sensors and affordable costs for massive markets. So we are focusing on potential for prevention measurements in area of smart health. How we do this is we are by selecting different sensors to particle matters, and we are basically distinguishing different, let's say, gases from polluting organic and inorganic matter within different gas mixtures. So we are focusing, as I mentioned, to deliver a sensitive and reliable sensor at low cost. Srq Project Consortium consists of 26 partners. We are from business to, let's say, university and research areas, academic research, and we are partners from 6 different countries like Czech Republic, Finland, France, Germany, Malta, and Netherlands, from where we receive the national funding. So if we get a focus, or let's say take a look at how we contribute to the Green Deal, so with this growing global awareness of air quality and its impact on human health, Srq is developing essential technologies for gas sensing. So what we focus on is an inclusive and economic solution for pollution, as I earlier mentioned, also focusing on low cost on the high volume sensor manufacturing. Besides this, we work on increased sensitivity and selectivity of different sensors to particle matter within different gas mixtures, from organic, as I mentioned earlier, to non-organic gas detections. So our focus is also in the project of miniaturization for the high volume capabilities. Also, we are focusing on something that is really important in this Green Deal. It's called basically low energy consumption of the sensors with all the added functionalities and features that we are introducing here in the project. Besides this, we could say that all these technologies could be applied later on in medical environment and for food, let's say, food safety to detect or identify any airborne pathogens. So we are working all together, as mentioned, to enrich the air quality empowerment for everybody. So if we take a look furthermore, how important for us is the collaboration with these different funding projects. So the collaboration is important from all areas, from big companies, from universities, and also for small companies as SME companies are. So what we focus on and how we collaborate here is basically we together work on research, we together form the huge knowledge base that is accessed for everyone. Then we benefit of this, and also we have access to new technology solutions and development areas, or let's say development ideas that are not maybe at the moment available in the market, but these research projects are helping us to get access there and get more knowledge, be ready for the market and be ready for new challenges that are coming. So out of these projects, we are getting also really good partnerships with big companies, research institutes, universities, and also getting a real contacts that we can furthermore keep and work on common business together. If we take a look on, as I mentioned earlier, from many of these projects, we get really good partnerships. We got, for instance, direct customer access to certain chips in a big semiconductor companies. Then we participate furthermore in some national and international funding projects by cooperating with different partners. So from one project to another one, the new collaborations are also being formed, and this is really a great opportunity for all companies, so from small size to big size companies. And therefore, we also, our uniqueness as a small company participating in this kind of projects is basically that, as I mentioned earlier, we have access to new technologies and always, let's say, getting by faster know-how maybe than the other competitors, just by having access to these knowledge bases and getting in contact with big partners. So that will be all from me, from my side. Thank you very much, and I head over to Charlotte.
Thanks a lot also for your presentation, and I don't think anyone can be against an improvement in air quality, and I'm sure your senses will be very beneficial. And what's also to be liked is that you have a very holistic approach, that it can be applied to the field of health, food, industry, so that sounds very promising. So thanks once again for your contribution. The final speaker, ladies and gentlemen, that we would like to give the floor to give his project presentation is Christian May, and he is the acting acting as division director of flexible organic electronics at Fraunhofer FEP, and this stands for the Fraunhofer Institute for Organic Electronics, Electronic Beam and Plasma Technology. Since 2003 he is with Fraunhofer, and technologies, processes and applications for devices with organic semiconductors are the focus of development work in his team. No need to say more, I would say, Mr. May, the floor is yours. May, the floor is yours.
Okay. Hello, everybody. Thank you, Charlotte, for kind introduction. I want to thank also the organizers to invite me to this discussion, and it's my pleasure to share with you our ideas and our visions we have on biodegradable electronics. As you see here on this sketch, we have some history in flexible organic devices. The most prominent one might be a flexible OLED, as we are doing it in the Pi-scale light years pilot line and so on. And by that, our thinking was it should be possible to make also degradable devices. We have thin organic films only. We can use degradable stuff. Please let us do it and let us start. And by that, we have now two columns where we are working. The first one is a vision which is dedicated to healthcare applications, and as the second one is going to a, yes, I don't like the word so much, low-tech application to include the biodegradable electronics, for instance, in packaging. For the healthcare application, we have the vision for absorbable implants for temporary application, and we have been able to perform together with other Fraunhofer institutes an internal project financed by Fraunhofer itself. Project was called BioElectron, to go the first steps for vision to have absorbable implants for temporary applications available, for instance, pre-surgical diagnostics of epilepsy and so on. We have our approach to bring the organic electronic technologies using biodegradable and biocompatible materials. Within the project, we have been able to provide conductive paths based on magnesium. We have now working organic silicon transistors available, which are close to the state of the art we have, but we know this will be a long-term story to have it really in medical devices later on. But to enhance the activities here and bring it to a market faster, by that we have identified to go to, yes, I don't like the word, but I don't have a better one, to low-tech application, and which is really a mass application which can be reached easily. And by that, we have here the attempt to use a fully degradable RFID tag for packaging. To make this passive RFID tag completely out from bio-based or even biodegradable materials, to have the benefit for the environment, to have, yes, all the security systems we know today, but we want to have it that it can be composted in at least industrial composting plants. We have our basic technology available using patterned magnesium on biodegradable polymer substrates available. And now we are looking for partners, at least from the packaging industry, but not only, to make really a product-related development work and to establish a manufacturing trace for it. And here we are lucky because we have a small but reasonable project funded by BMBF to be in an exploratory phase and to look for partners and to propose a project for BMBF later on for a larger one. And by that, yes, we are looking for partners. Please give me a call. And especially also the German partners are invited to join us here. Yes, why we think that biodegradable electronics is really a contribution to the Green Deal. Yes, by that we have the general question, of course, why we need biodegradable electronics. We have highly sophisticated silicon-based electronics, and from what we know now, we will not be able to reach such a performance during the next decade. But by that we have to distinguish. We have the advantage to use the biodegradable electronics in case it must be completely degraded, for instance, like in the healthcare application. Or on the other side, we can use the biodegradable electronics in case we have to go for large area applications. Antennas, like for the RFID tech, also the light emission activities, photovoltaic activities, which can be degradable and so on. And by that, this problem cannot be solved by the miniaturization to have a silicon devices, a small sun crane, and so on. Here we have to have the biodegradable electronics. And it fits well with the European sustainability goals, and of course, primarily addressed, we have here the circular economy as a #1 priority. Okay, yes, by that, we claim that biodegradable electronics brings sustainability to the electronic products and electronics to the sustainable products. By that, we claim that it will be possible to have new business opportunities for European companies for sensors, intelligent packaging, health and well-being, and so on. Yes, we will have much more IoT-based devices. Electronic waste will be increased, and therefore we have to bring it down. And by that, yes, it is very essential that we have this topic also in the strategic research and innovation agenda, as you can read here. This is a major topic. We can play with this, and therefore it is here also on the short-term and medium-term topics in the roadmap included. And I think European approach is very essential here to have the synergetic use of the excellent competences spread over all Europe. It is essential to have the connection with our flexible electronics community. By that, we can use our excellent network of the European RTOs, for instance, Fraunhofer FEP and IZM proposed together with the VTT as a Sustonics proposal. Perhaps you have recognized it yesterday. And I can offer to you also to use different digital innovation hubs. We are involved in Smarties to bring flexible, hybrid, organic printed electronics to your product IDs. We are ready to start something together with you. Let's do. And of course, I have to claim that, yes, we need also support. It means also funding for all the critical TRL range, the so-called valley of debt, to bring the technology from the research to the products and bring industry and institutes together. Thank you.
Thanks a lot, Mr. Mai, for your presentation as well. And I think, well, you can be very happy for the fact that your topic of biodegradable electronics has been taken up in the SRIA, so that is indeed very good. And also, once again, if you would like to collaborate with Mr. Mai, because there was a specific call from his side, of course, you're more than welcome to reach out to them. Okay, ladies and gentlemen, we'll now have a short panel discussion. And I'd like to give the floor first, perhaps, to Paco, because the line was pretty bad at the beginning, and I know he still wants to give the on the Green Deal. And I can already tell you, Paco, we also got a couple of questions in from the audience because they would like to know more about it. So I'd like to give the floor to you first.
Excellent. Thank you, Charlotte. Yeah, thanks for the question. Yeah, basically, I think one of the questions is what the Commission is taking as a concrete measures to really deal with the green ambitions. So I think we are all aware that with the new Commission entered into operation back in December, the very first line that President von Leyen brought was the Green Deal, the European Green Deal. And she has put in charge of developing and implementing the Green Deal to the first Vice President, Mr. Timmermans. So just to tell you that from the political point of view, is certainly a very first priority. So the overall ambition, as we all know, is that Europe is the first continent that by 2050 it is climate neutral. That means that the net level of emission will be exactly zero. Again, we are talking on an objective which will happen in 30 years' time. So this is certainly a long shot. So we are trying to see how can we become more operational. And sorry for again, the cat is just coming. Sorry about that. The first operational objective milestone is going to be set exactly in 10 years' time. In 2030, we are putting the level of emission to a reduction of 55%. So this is a concrete measure. It was initially 30% and has been raised, the bar in terms of ambition. So now, in order to implement all these challenging objectives, there's an action plan that has been put forward. And this action plan includes the legal basis, and there is a climate law that is being proposed and is in the approval process. This is a financial plan, because the estimation is that the financing of this Green Deal objective is in the region of 260 billion euro per year. And there is also a plan in order to make this financial possible, including carbon taxes. But also something we tend to forget sometimes are the social implications of the Green Deal. You had to think that today in Europe, there are countries, there are regions on which the economy depends heavily on energy production using fossil technologies that are certainly not friendly from the environmental point of view. And again, we have to help those regions, and we have to help workers to get through the transition in a way in which no one is left behind. So this is also part of the Commission plan for the Green Deal. So this is at the global level, and it's clear that Europe is not alone in this game. This is a global challenge, and we all need to work together towards. Now, if we go down to the level of electronic component and system, to our community, what can we do to contribute to those objectives? I think first we need to take into account that from the research and innovation point of view, this political priority is going to be translated in a very direct mode. As an example, we are going to invest 35% of the whole framework program budget into technologies that one way or another are going to contribute to those objectives. So going back to Michal, when he made the statement that addressing green in your proposal increase your chances, I can tell you, in projects in Horizon Europe, whether in partnerships or in the work program, you do have to address the green aspects. You have to, in the part of impact, you have to tell to which extent your technology, your project will contribute. And on that, let me just go one level further. We tend to focus on the energy saving, reduction of energy consumption. This is, of course, very extremely important. But we are talking about this is how electronics operates during the lifetime, where the device is functioning, when the device is in the field. Sometimes we tend to forget that there's a production stage, and there's a design stage that we had to go through first. So there is already an impact, a negative impact of electronics in terms of production, in terms of emission, in terms of waste, in terms of recyclability. We have to take that also into account because, again, Europe also have an impact on production. we have our further production, and the technologies that we develop are somewhere taken into the production cycle. And it doesn't matter if this happens in the European territory outside. The impact is the same. It's for all. It's for the planet. Okay. And then I will just elaborate a bit on a point that Stefan has put forward, and that I totally agree, which is the metric. I think it's important not only to be able to give an estimation or an idea or a flavor or to which extent our technology, our process, our tools are contributing to the Green Deal, but also have to make an effort to quantify. We have to quantify the impact. And again, metric is extremely important. It's extremely difficult to try to make progress towards an objective if we don't see how much we are making in every step towards that final objective. So I will leave it there. So we do have concrete plans for, I would say, at the higher political level, but also for the research and innovation community. We really want to make sure that we are a contributor. We are really part of the solution, and we are putting forward effort in every single project we do and every single thing we develop to make sure that by 2050, Europe is really the first continent that is going to be climate neutral. Thank you.
Okay, thanks a lot, Paco, for this elaboration. Much appreciated, because this is where I also would like to make the connection between the policy side and the program level. Because Paco said the ambitions of the Commission are very clear. It's a key priority of the Commission von der Leyen to focus on the Green Deal, emission reduction of 55% by 2030 and Europe climate neutral by 2050. Now, my question is directed towards Mr. Brunier, Ms. Majstorovic, and also Mr. Mai. Do you think, from your perspective, that these Green Deal objectives are realistic? Because we always should balance the ambition on the one hand, but also being realistic on the other hand. So perhaps, Mr. Brunier, can I give you the floor first?
Yes, thank you, Charlotte. The objective is feasible. Well, yes, the answer is clear. At least I hope so, because we don't have many alternatives worldwide. If Europe cannot make it, I don't see many other alternatives. So clearly, what I see that is Europe has identified the right axis of optimization of our ways of production, reduction of our consumption, circular economy. That's clear. They have paved the way. Now we have to execute that, and to become successful, like in a project, it must be a virtuous circle. In other words, I think we have to make a win-win approach. Let me explain a little bit with a concrete example. In our electronics industry, many companies inserted Green Deal and ecological mindset in their policies. It is not only a benefit for the image, but financially it is interesting. For instance, between 2016 and 2020 in Soitec, we divided by more than 2 the amount of electricity and water needed to fabricate a single wafer. And this is continuing year after year. So for Soitec, it is an optimization of our ways to produce, leading to reduction of fabrication costs. But for the Grenoble area, this is an insurance that our industry is taking care of the drinking water. So win-win approach here. And to make the Green Deal a reality, this challenge is really to propagate this virtuous circle along the value chain and up to the final consumer. That must be an ecosystem-wide approach, or a systemic or collective effort, as you want, and with a homogeneous and trustable common metrics.
Okay, thanks a lot, and also for making it so concrete, because of course the objectives are set on a very abstract level. But with your example of Grenoble, you also showcase that this local ecosystem, in that sense, is very important. That at the local level, you need to see the changes of the kind of policies that have been and the objectives that have been set top down. So thanks a lot for that, much appreciated. Ms. Majstorovic, what's your vision on that? Is it realistic? The ambitions?
Yeah, I would say so. I think it's pretty realistic. I can comment what we are doing in the project.
Please.
Basically, we talk and we focus also from, as Mr. Paco explained, we focus also on the manufacturing. We start from technology and focus on manufacturing to have the low costs work on the green deals, focus really to have concrete solutions that will be used later on. Also, not just in environment, as one of the green objectives is to have a clean environment in green deals. We also focus on the health to bring benefits and also find different applications where we can apply our research results, actually. We also focus, as I earlier explained, to different selectivity of the sensor, which is also a really important thing because later on, if we can, as I mentioned, apply this to different applications, it would help us to really achieve the green deals, also for some new projects, and definitely improve air quality, as something was discussed in the Paris on the climate change conference. This is really an important topic. And I must say now, if we connect this with the current situation in worldwide, for instance, air quality has become really important and crucial topics, as also as Mr. Mengele talked about later, the CO2 emissions and so on. It's really important that we focus also to get a low cost of manufacturing of these kind of sensors, because still, I must say, the market, the sensors are pretty expensive, and therefore it's getting difficult really to integrate this in the systems and to provide cost-effective solutions for all kind of customers. So from the customers on the business areas, but also to customers, let's say in the home area, for example, for smart home solutions and so on.
Precisely.
So we really need to focus on low costs in manufacturing side, to get good solutions and with additional features to distinguish different kind of gases, not just the currently available sensors.
Thanks a lot. So low cost is definitely something that we should take into consideration in able to achieve those objectives. Then the final word I'd like to give to Christian May, because we're almost running out of time. Christian, what's your comments?
No problem. I can make it short, very short. The question was, are the objectives realistic? And the short answer is, it has to be realistic. And let's start to make it realistic with all the different approaches we have coming from
almost running out of time. Christian, what's your comments?
No problem. I can make it short, very short.
Okay, so thank you so much. Ladies and gentlemen, I think this is unfortunately already the end of this session. It's a pity we couldn't contribute concretely to the Green Deal objectives. And once again, to everyone, if you have a certain vision on how to do that, of course, you can direct your questions to the European level, to Mr. Paco Ibanez, but also I'm sure on the member state level, for example, in Germany. And of course, your vision is also very important to further outline the ECS strategic research and innovation agenda. So thanks once again. We will now have a short break until 11:15, and then we're going to start with an award ceremony, but I'll tell you all about it later. Thank you very much.
with your video on, but that screen in the end turns into the video. So you don't have to say
Okay, ladies and gentlemen, I hope you had a good break, and as already announced, we are now going to have an award session, and we're very excited about that because we talked about different policies for the electronic components and systems industry. We already talked about some projects, and now we're going to focus on some of them that we can rightly coin some pearls within the community. And ladies and gentlemen, the first award that will be handed out is the Penta Innovation Award. And thereafter we'll discuss with you an ECSEL Award and also a Horizon 2020 Awards. Well, the first one is part of a Penta healthcare project named DISPERSE. And DISPERSE started on the 1st of February 2017 and finished on the 31st of January 2020. The project was primarily initiated to develop electronic solutions to MRI scanning, and the DISPERSE project succeeded in removing many of these limitations? Well, the total investment in the project was about 10.7 million euros. And there was a really specialized group of participants which actually contributed to the success of the Spurs. And you can see all the logos of those participants in the consortium on the screen. Now, ladies and gentlemen, of course, I would like to switch to the proud project coordinator from Philips Healthcare named Mark van Helvoort, and he will explain to us how the results of DISPERS will influence the MRI examination of patients with multiple implants. I would say, Mark, the floor is yours.
Thank you, Charlotte, for your kind introduction. Indeed, I'm very proud to stand here and to share the achievements of the DISPERS project with the audience. In turn, I would like to introduce my son to you. This picture of him was taken in the University Medical Center of Utrecht at the age of 4, some 15 years ago. He is epileptic and standard treatment with pharmaceuticals does not work. In Utrecht, they assess if brain surgery is an option. Here he is undergoing an EEG to measure the electrical signals from his brain. This is not enough, because also an image of his brain is needed. Therefore, he is referred to magnetic resonance imaging. Magnetic resonance imaging, or MRI, is a large piece of equipment which is particularly useful for imaging soft tissue. Over the last 30 years, it has evolved to the golden standard for neuroimaging, which is depicting the brain and the spine. In contrast to X-ray and CT, it does not use ionizing radiation, but employs large magnetic and radio frequency fields. In case of my son, it turned out that surgery was not an option. Fortunately, active implantable medical devices, shortly implants, were emerging. We decided that our son would participate in a clinical trial for implanting a vagus nerve stimulator. This implant is connected to the left vagus nerve in the neck and continuously delivers electrical pulses to the brain. So, statistically not proven, we believe that the implant worked very well for our son. However, we found out that further diagnosis became problematic. MRI was contraindicated because the large fields could damage the implant and it even could harm our son because the implant lead acts as an antenna for the RF field and can heat up the surrounding tissue. Of course, doctors, MRI manufacturers and implant vendors throughout the world are aware of this problem. Actually, it caused doctors to be reluctant to implant these devices, and it is only as very last resort when everything else failed. Both from a medical and an economical point of view, we needed to change this situation. We, as electronics industry, need to create implants which can coexist with MRI. This is only possible through collaborative innovation projects and joint standardization activities. At the start of this course, technology was available to scan patients with one implant at the cost of examination time. With an increase of the use of implants, the number of patients with more than one implant becomes significant. If you think this is rather far-fetched, I would like to introduce you to Simon Schaefer. Until he was 6 years old, Simon was nearly deaf. His hearing was restored with a cochlear implant on the left side. At the age of 12, he received a second implant on the right. With 2 implants, he is able to also hear in noisy environments like restaurants. This enables him to fulfill his dream to study at a regular university. Currently, at the age of 26, he is studying at the Karlsruhe Institute of Technology and has a part-time job at IBM. In addition to tackle the challenge for multiple implants, we developed electronics allowing faster MRI scanning. To improve MRI sensor technology, we joined forces with the Netherlands Institute for Radio Astronomy. They are working on new architectures to replace these huge disc-like antennas by arrays of much smaller antennas. With this technology, MRI will be able to scan patients with implants as fast as regular patients. Concrete, this burst delivered miniaturized and power-efficient RF receive electronics and communication photonics. I would like to conclude the achievement section of this presentation with David Mengele. David was a student and athlete back in 2010. He broke his neck when jumping off a trampoline, and he was told he would never be able to walk again. Thanks to the groundbreaking work of Professor Grégoire Courtine at APFL and a multi-electrode implant lead developed by Disperse, he is now able to walk again. The great results achieved by the Disperse project would not have been possible without a great team. I would like to thank all participants for making dreams come true. Of course, I would also like to thank the national public authorities and the Penta program office in supporting us throughout the project. To conclude my presentation, I would like to recapitulate that the AENEAS project DENICOR delivered technology to scan patients with one implant. Disperse strongly reduces the examination time and allows patients with multiple implants. And next year, the PAVIS project will start, and PAVIS will embed artificial intelligence directly into MRI and implants to personalize diagnosis and treatment. Thank you for your attendance.
Thank you so much, Mark, for your kind presentation. Also good to see that you will have a follow-up project. And wow, this really is a healthcare success story and also a very unique personal story, I would say. And that you enable people within this project, at least also young people, to give them a proper future. And what's also very nice is that you managed with this project to really concretely show the impact on society and the impact on citizens' lives. And I also have a question related to that for you, Mark. And that is actually, well, the dispersed technologies are now very much limited to the healthcare field, but can they also be applied to other domains?
Thank you, Charlotte, for asking if the technology developed by Disperse are also applicable outside the healthcare section. And actually, within the project already, we brought together 3 application areas. Next to healthcare, we had radio astronomy, and we had smart cities. And in the smart city application, we developed arrays of sound cameras which can detect street violence, such as shouting and gunshots.
Okay, thank you very much, and the best of luck in your project and the successor project. And ladies and gentlemen, of course, I'd like to hand over also to the proud Penta director. I'm sure he's very proud of this, and that is Peter Connock. And well, we are here virtually, but I know you are going to hand over that award to Mark. So Peter, I'd like to give the floor to you for your kind remarks.
Yes, thank you. Certainly proud. 2020's turning into a pretty good year for Penta. We've just launched our latest call yesterday with Euripides, and now we are seeing the results of our very first projects that started 4 or 5 years ago with this Disperse success. So I really am delighted to have the opportunity to present this first Penta Innovation Award. As we know, all of these projects are designed to stimulate collaboration, push the state of the art, and really begin a new generation of technology. And but there has also to be impact. There needs to be economic impact, and also, wherever possible or wherever appropriate, societal impact. And as I think we've all just heard, Disperse ticks all the boxes. In essence, the MRI is a vital tool in healthcare for the aging society and the challenges faced by multiple implants, as Mark has demonstrated. But not only has that core area of the project been successful, but as Mark just said in the question, the technology can be used in broader applications as well, in space communications, in smart city safety, and there will be more, I think, that can come out of this project as it develops its exploitation plan. So all in all, it ticks all the boxes. It's an absolute deserving winner of the first Innovation Award. And with that, on behalf of Penta, I'd like to, by the magic of the cloud, present the Penta Innovation Award. There it is. It's appeared with Mark to the Disperse team, with Mark accepting it as project leader on behalf of the entire team. thank you very much. And I hope we can also have a virtual round of applause.
Of course, thank you so much. And I'm going to give you an applause for sure. So thank you so much. Mark, do you have a final word for Peter?
Yes, of course. I would like to thank Peter and his team again for all the support they gave. I was very proud to be the piloting project. We were the first project to start, and we were the first project to end. We are the first project to end to receive this very nice award. And as Charlotte already said at the introduction, I am very proud, and particularly at my great team. Since this project has to end, of course, but we will meet each other in other projects and other times and continue the success. See you again, and thank you.
Thanks a lot, and the best of luck, and make sure you don't drop the award. Thanks a lot. So, ladies and gentlemen, we're now switching to the next award winner, and this is the project Mnemosyne, and this project started in January 2018 and is part of Horizon 2020, the European Union's Research and Innovation Framework Programme. The purpose of the project is to address major limitations of today's computing architectures and technologies used to implement them. This is done by developing new computing engines being able to enable cost-effective computation of currently infeasible applications fueling important societal changes, including personalized health, drones, smart environments, smart robots, and so on and so forth. The European Union's investment in the project is about 4 million euros. And as you can see on the slide, there will be, or there have been so far, a project consortium of 9 different partners from 7 different European countries. And now I'd like to switch to the proud project coordinator, Professor Dr. Said Hamdiou from the TU Delft, who will explain the results to us and the importance for the European positioning in this technology area. So Professor Hamdiou, I'd like to give the floor to you and hand over to you.
Thank you, Charlotte, for the introductions. Good morning, everybody. I will use the next 5 minutes to introduce you to Mnemosyne and show you how this project sets a strong step towards low power or green edge computing. So let's start first with the opportunity. So as you can see on the left side picture, the number of Internet of Things, IoT connected devices are increasing or is increasing. It will reach 80 billion in 2025. Connected IoT combined with edge computing, as you see on the picture on the right side, provide a unique business opportunity. Edge computing means doing computing and extracting the information locally, where the data is generated, which means not sending the data to the cloud to extract the information. Think about deploying intelligence at the edge in a personalized healthcare wearable device, for example. But this kind of computing has specific requirements, as you can see on the slide. I will pick just one. That's the energy constraint. The energy budget is very limited. A device, for instance, should operate based on a battery. So now let's take a look at the energy distribution in today's computing engines. The picture shows a simplistic view on a conventional computer consisting of a processing unit called CPU and a memory where the data is stored. Let's use a simple operation, A plus B, to illustrate how it works. To do A plus B, I will need to move the A from the memory to the CPU, move B again from the memory to the CPU, and do the addition, and actually finally bring S back to the memory. If I would do the same thing C plus D, I would do the same thing again, data movement. You can clearly see that, we have to do with a lot of data movement. The question is now, how much energy consumes this data movement as compared with the actual computing? On the table, you see that the actual computing, which is done by the processing unit, consumes 0.05 picojoule. Let's say 1 energy unit. Data movement of chip in this case consumes 6.4 thousand times more energy. And clearly you are interested in computing and not in data movement. So you can clearly see that we need new architectures if we really want to reduce the energy consumption. Another equally important aspect is that related to the technologies used to implement such architectures. They are volatile, meaning they waste the energy called leakage power, as you can see on the figure on the right. Even if there is no activity, you are losing the energy. Dynamic power is what we actually consume when we are performing actions. So the figure clearly shows that the leakage power increases as the technology node decreases, reaching unacceptable levels. More than 50% of the total power for 20 nanometer technology will be consumed as leakage power. Meaning, in fact, that we are wasting more energy than what we are spending on actual computing. Again, this is not acceptable. Therefore, we need new technology devices if we want to save the energy. So in conclusion, we need newer architectures implemented using new device technologies. And that's exactly the purpose of our project. Our project explores alternative architectures in the light of emerging non-volatile devices. Let me again use the same picture we saw before to illustrate how the computing will be different. So, and again, I will use the same operation, A plus B. So in that case now, what we will do, I will do the computing inside the memory. Rather than moving the data to the CPU, I will do the computing inside the memory. Hence the term computation in memory. Moreover, this architecture allows me to do parallel operations again within the memory and without moving data back and forth. You can clearly see that same architecture significantly reduces data movement and enables parallel computing. Moreover, actually, we are using emerging memoristic devices to implement such architectures. And emerging memoristic devices, they are non-volatile, which means that their leakage is practically zero. Combining these two concepts, same with emerging technology devices, we are aiming at improving the energy efficiency and the performance efficiency with a factor 10 times to 100 times better. Well, let's see if this is a dream or a reality. In partnership with our collaborators, and in that case specifically IBM, we manufactured a small chip, as you can see on the picture on the left side, with performed measurements, and we used extracted information to build accurate circuit simulator. We did experiments with a database consisting of 303 patients and featured with 41 attributes or heart diseases. We chose an example of a query consisting of 11 consecutive operations. What we found, that we can perform 11 steps in no more than 36 nanoseconds. What does it mean actually? We can perform almost 100 giga operations per second. And giga operations, giga means 1,000 millions. So we are talking about 100,000 million operations per second. What about the energy? The total energy we spend to do this 11 steps is 20 picojoule. And a pico is 1 from a trillion. And in terms of the energy per operation, we are talking about 6 femtojoule. And what is a femtojoule? Is 1 from a quadrillion. And this is exactly the figures and the numbers and the order of magnitudes we need for edge computing and for deploying intelligence at the edge. And we heard this morning and also yesterday the importance and the mass of having edge computing. So finally, how does this actually position Europe? First, it will enable, the Mnemosyne will enable economically affordable solutions, being able to bring intelligence to edge applications and battery-driven devices. Number two, it will set up an important step towards neuromorphic computing, in which computational memory is essential to mimic the brain. And last but not least, it will put Europe in a leading position when it comes to emerging computing paradigms using unconventional technologies. So thanks for European Commission and for EDGE 2020 for sponsoring these projects, even after we tried it 3 or 4 times. And finally, I would like also to thank the partners for the outstanding job in order to realize our achievements. And thank you for the audience and for listening. Thank you.
Wonderful contribution, Professor Hamdoui. And as you pointed out, we need these kind of new architectures in order to reduce energy consumption. And ladies and gentlemen, we do have an answer, because Mnemosyne is your answer. And I also see a lot of links, for example, where you said, Professor Hamdoui, is that this edge computing is very important. What we've seen this morning already is that it is definitely one of the key priorities also within the broader strategic research and innovation agenda of the ECS community. One question for you, Professor Hamdoui, and that is basically, what does the use of AI mean for future computational technologies?
So thank you, Charlotte, for the question. Actually, we do believe that if we're gonna make use of artificial intelligence, as we know, AI, artificial intelligence, is changing the way we are actually living our daily life. And it has been already in wide use, think about, especially in the big machines in the cloud. Think about Google, Facebook, etc. And if we really wanted to deploy this intelligence at the edge, close to people, think about a personalized healthcare. When we're going to deploy wearable devices equipped with intelligence. In this case, we can only do that if we are able to develop ultra low power computing engines, for instance, which can operate, as you already mentioned, on a battery. And this is where you really need this kind of architectures in memory computing as one of the potential alternatives. And we do see, and we strongly believe that Mnemosyne, or the concepts developed in Mnemosyne, can strongly help in bringing intelligence and artificial intelligence close to the edge, which is not there yet today, especially for applications which have extremely low budget constraint when it comes to energy consumption.
Okay, wonderful. And I can definitely see, Mr. Hamdoui, you're very convinced about the solutions that your project offers as well as your colleagues. But I also would like to turn to the European Commission, because they thought it was very convincing as well. And it is my great honor to introduce to you Nick Catavenas, who is the policy officer for the competitive and electronics industry at DG Connect, also a colleague of Paco, whom you've seen already earlier today. So Nick, you also must be a very proud person right now.
Indeed. Thank you, Charlotte. You can hear me, okay?
Yes, I can.
Great. Good morning, everybody. Indeed, and I'm very happy to be in this position today to represent the Commission in handing over the Horizon 2020 Innovation Award under the Efecs event. And for this, I would like to thank Professor Hamdoui for this excellent and clear presentation. And indeed, I can only just repeat that, coincidentally, this project actually covers many of the topics that we've been discussing since yesterday, also for the upcoming framework program that we're supporting in research and innovation in terms of computing at the edge, processing, AI, low power, greener technologies. And for this, I'm very happy that Mnemosyne was the winner this year. I must say that, just to repeat a bit of what Peter Connock already said, in these projects, it's only evident when you look at the partners involved that we have clear evidence that the technology developers are there and it's going to be a success. But this can only be done by collaborative projects. And I think this is an extra element that we bring by providing the EU funds to these partnerships. And so thank you also to Professor Hamdoui for trying, as he said, a few times before reaching here. And we're very happy for the project results. and the success. I must say that we go through this process every year for the award, and we do receive a lot of applications and some very excellent projects. And for this, it's only fair to actually mention that we did have 2 runner-up projects from different fields, one on health, which was Madia, and one on the micro OLED, which was Milady. So congratulations to them too. They came close, but of course, there can only be one winner. And for this, it is my honor to, on behalf of the Commission, on behalf of DG Connect and Directorate A, to hand over the Horizon 2020 Most Innovative Project to Mnemosyne. Congratulations once again.
Thanks a lot. And I think, Professor Hamdoui, could you keep it up a little bit higher so we can even see it better? Yes, perfect. Thanks. Lovely to see. Do you have a final remark or comment for Nick, Professor Hamdoui?
Now, we would like to thank again the European Commission and its 2020 program for funding and supporting this project. And we are also extremely happy to see that these topics are also included in the upcoming programs. We heard a lot about edge computing, AI at the edge, low power, green, etc. These are all terms that comes closely to our research interests. And I will say just expect new projects in this direction. We will follow our project in this direction. Thanks a lot.
Thanks also for your kind words, and the best of luck with the follow-up of the project. Thanks. So, ladies and gentlemen, yes, exactly. Thanks. We're going to switch now to the final Pioneer Award awarded by the ECSEL Joint Undertaking. And this year the award goes to Toronto, and the award has been extended beyond projects that excel in dissemination to also include those that have shown exceptional technological advances. And therefore Toronto has been selected. Toronto started in April 2017 and aims at strengthening the leading position of the European semiconductor industry. The technologies developed by Toronto provides a solid industrial base for the development of new products in areas such as telecommunications, industrial, personal and car electronics, which are of key importance to Europe's high-tech industries. The ECSEL's investment in the project is, ladies and gentlemen, 43 million euros. So that sounds very promising in terms of budget. But also if you look at the project consortium, they consist of a total of 32 participating organizations. And those are the main European players in the complete value chain, from universities and laboratories to industrial users located in 6 different countries. And now we are going to watch a video which has been produced also kindly by the project leader, I would say, Pierre-Jérôme Joran from ST Microelectronics. And if we can please put the video on the screen, that would be wonderful.
Thank you, Charlotte, for this introduction. Great thanks to the ECSEL organization to offer this great opportunity to the Toronto Consortium to present the Toronto project. Toronto was started to solve challenges in telecom speeds brought by 5G and in detection precision of radars brought by autonomous vehicles and robotics. 5G's deployment requires 10 times greater data speeds due to volumes to be transferred, like for videos, and to the multiplication of data sources due to ubiquitous fixed or onboard sensors. Autonomous vehicles and robots requires radar's detection precision to improve by a factor of 10. To enable these, Toronto's objectives are to develop BiCMOS silicon semiconductor technologies, targeting to reach 50% better speeds and power efficiency, and integrated circuits and systems for more efficient telecommunications and radars for safer roads and public spaces. To meet these challenges, European industrial leaders in telecommunications and radar detection systems, such as Nokia, ST Microelectronics, Infineon, SIAE, have joined forces with a total of 32 highly motivated partners, having demonstrated great collaboration in previous projects. They represent the complete value chain for the realization of the demonstrators of systems and thus allow the expansion of a remarkable European ecosystem in BiCMOS technologies. While the competitive positions of the partners stay, this collaboration strengthens their leadership and sovereignty of Europe. This demand for speed and reduced power consumption by the telecommunications and radar industries poses enormous challenges to semiconductor manufacturers. The best positioned to overcome them are the world leaders in BiCMOS technologies, STMicroelectronics, Infineon, and AHP. Their new technologies, developed in Taranto, set new state-of-the-art levels with speeds at 700 GHz, thus 50% higher, obtained by AHP for small series, and currently 495 GHz, thus 25% faster by Infineon, and soon plus 50% by Infineon and STMicroelectronics for mass production. For the sake of instantaneous information availability from the cloud to your smartphones, the speed of optical fiber links must increase endlessly. A new step has been taken in Taranto with a tremendous world record in speed at 1.52 terabyte per second over 80 kilometers. To help 5G deployment, costly optical fiber installation can be replaced by lighter wireless beams with very high speed, which are developed in Taranto, like the 5G wireless repeaters to deliver internet access to homes, and the 5G wireless data hauling system for connection to the core optical fiber network. A 6G precursor transceiver is currently developed in Taranto. Taranto develops radar systems with millimeter positioning accuracy to improve the control of moving robots in large storage facilities, then to enhance the connectionability of your smartphones to home devices with compact radars having half a watt consumption, and finally to enable new applications such as the evaluation of health vital constants or indoor spaces observation with a pulse radar having low transmit energy milliwatt consumption, very low cost. Taranto has enabled STMicroelectronics, Infineon, and AHP to reach a fantastic position with the new BiCMOS technologies. When the industrialization will be soon finished, this level of speed and energy efficiency will not be found anywhere else in the world. With the tremendous traction resulting from the world record in speed for optical telecommunications held by Nokia and Micram, Taranto is enabling outstanding new products to emerge. Highly innovative 5G and even 6G wireless systems will be industrialized by Nokia, Infineon, and SIAE. Taranto largely widened the domains of radar utilizations with economical, efficient, and accurate solutions developed by Infineon, DICE, and EUREKA. To conclude, Taranto has provided a unique frame to competitors to become partners in a world-class and efficient collaborative ecosystem for BiCMOS technologies. And this is key to maintain their world-leading positions. Through these leading positions in key technologies and systems, Taranto also enables Europe's sovereignty reinforcement on data control. Taranto's tremendous achievements in telecommunication systems will enable reduced energy consumption and healthier environments with more directional wireless beams. The outstanding results obtained in radar systems are essential to improve road safety, security in public spaces, homes and vehicles, and benefit the industrial and health sectors. On behalf of the Taranto Consortium, I greatly thank the European Union, national public authorities, and professional organizations for their
It's a kind video, and it definitely shows the excellence that you display within this project. And well, ladies and gentlemen, yesterday already talked about how to put Europe in a leading position. And my question would be also to Mr. Joran, is you mentioned that this technology development in Toronto actually puts Europe in the lead. So I was just wondering, what does it take to make sure that Europe keeps this position? I'd like to give the floor to you.
Yes, thank you, Charlotte. Indeed, this is a good question, how to stay in the lead. So, as we saw in the video, Taranto performed very well, and not only because of the fundings, even if this is important. What made competitors like Infineon and ST collaborate in this unique frame provided by ECSEL is that expert partners such as research organizations and also academic and university labs that help them to develop the technologies and also help them to show the tremendous results of these technologies with the help of industrial and
and end users partners like Nokia and SIAE, for example, which build system demonstrators which show these outstanding performances. So in this frame, every partner has been a winner, in fact, and with the emergence of new products and new technologies. And to answer your question, what we need right now is to go for the industrialization phase. It's industrialize the systems and the technologies that Taranto has developed. And for this, we have, in fact, we have already submitted a new project in the ECSEL frame. So
okay,
for this question.
Thanks for this contribution. So I think it's very much in line with what was discussed yesterday as well, is that of course the funding is very important, but then also the collaboration. What's so nice about these kind of projects, such as this ECSEL project, is that the basis of this is collaboration within a wider ecosystem of industry and academia. So thanks a lot for that. And I'd like to switch to Anton Chikov, who is the program officer of ECSEL. And I am very pleased to give you the floor, because we're also happy to hear from you, your vision and view and comments on this project, Taranto.
Thank you, Charlotte. Well, one of the main objectives of ECSEL is to make the European ECS ecosystem competitive. And in this sense, the selection of ECSEL fell to Taranto because they have made the fastest HBTs in the world, and in addition, managed to build them into a very high density CMOS process. At this moment, it is as fast and as dense as you can get. With these accomplishments, the project has propelled Europe into a pole position in this crucial technology. And why is it crucial? This new generation of HBTs will be a key factor in speed communications systems like 5G and later, as well as in the very dynamic field of connected, cooperative, and automated transport systems of the future. So with all this project has also drawn international attention and has been recognized as a breakthrough. And as a consequence, some of the other regions are hurrying up to put money into similar projects to try to catch up with Taranto. So you can imagine we are very happy and very pleased with what Taranto has achieved. So at the end, I have to say it has been a pleasure to work with this consortium. They have managed to create a very good team spirit, although they are from different companies and sometimes competitive companies. But more importantly, they are very dynamic, very professional, and very accurate in the execution of the project. So I would like to thank again the whole team and congratulate them with this award. And it is my pleasure on behalf of ECSEL GU to hand this award to Taranto. The award is yours.
Thanks a lot, Mr. Chikov. And indeed, I can see a very proud Mr. Joiran as well with his award. And how nice that apart from the awards, you really have this worldwide recognition. What more can you ask for? Perhaps, Mr. Joiran, do you have a final closing word? Anything you would like to say to Mr. Chikov?
Yeah, sure. Anton has been very good in describing the project spirit and the consortium spirit. Very nice people, very professional, very accurate, very available, very flexible also. So I thank Anton, but I think the whole Taranto team as well. And we hope to go on with a further project with the next phase. Okay. It's really a big hope. So thank you again, Charlotte and Anton.
Thanks a lot, and also for you the best of luck, and keep up the good work within your project. So ladies and gentlemen, of this specific award session, and what's so nice about that and this whole event is that we manage, with the help of you and with the support of all the people from the European Commission, but also from the member states and from industry, to have a broader overview of what the ECS community can do, not only the abstract level on the policy, but also how this really translates into very concrete and excellent projects. And we're not finished yet, because now, ladies and gentlemen, you have the opportunity to join some parallel sessions to discuss even into more detail some components of the strategic research and innovation agenda for the electronic components and systems industry. And those 3 sessions are the so-called lighthouses. And there's a lighthouse on mobility, there's a lighthouse on industry, and there's a lighthouse on health. So you're more than welcome to log on there, and I'd like to welcome you back at 1 o'clock for a final word to you. So thanks once again, enjoy the sessions, and we see each other later.
And then I noticed some difficulties, but
yeah,
good to hear that it seems to be less today.
And so this is now also a session I contribute, and this afternoon I'm still in a panel discussion on the Connect workshop on 5G and 6G, so it's a busy day.
All day Efecs, yes.
Yeah.
All right, I will mute myself now. We're 10 seconds away and then start.
Dear ladies and gentlemen, welcome to one of the ECSEL parallel sessions covering research priorities for electric, connected and automated mobility. My name is Caroline Zachius and I will moderate this session today. So before we will start with the program, I would just like to clarify that, as I guess in the whole Efecs conference already, the questions can be asked to all the presentations using the chat window. And then we will collect the questions and the speakers will have an opportunity to answer them orally directly after their presentation. So let us now briefly have a look at the session program. Some of the main topics during the conference were the current and continuous changing challenges for the ECS community. And in this session, we will further focus on challenges as well as research priorities for the application field of mobility. So, as we can see in the agenda, the session will start with an introduction to the Mobility Lighthouse, followed by a presentation of the Srq chapter and the underlined ECA mobility challenges. Afterwards, we will hear about research priorities for connected shared mobility. And at the end, we will highlight the smart infrastructure for the development and evaluation of automated functions. So I would like to warmly welcome the speaker of the first presentation, my colleague Benjamin Wilsch from VDI-VDIT. Benjamin is scientific consultant in the Department of Future Mobility and Europe of VDI-VDIT in Berlin, in Germany. His activities mainly concern future trends in transportation and include project and program support for several German ministries. And he is as well the project coordinator of the Cosmos project, which is driving the Mobility Lighthouse for the evaluation of the European ecosystem for electric, connected and automated driving. So please, Benjamin, we are looking forward to your speech.
Thank you very much, Caroline, and thank you for the opportunity to present the Mobility Lighthouse here today. I hope my slides are visible. If not, I would just ask for a short hint from the organizers. I will get started to not to lose any time. Yes, so the Mobility Lighthouse is of course all about the application field of mobility. It is one of 3 lighthouses initiated, installed by the ECSEL Joint Undertaking. And the main objective, if we had to put it in one sentence, is as we have it here on the slide, strengthening the ecosystem for electric, connected and automated mobility. There are a couple of additional logos on this slide. I'd like to point particularly to one of the Cosmos project, which is the CSA behind the Mobility Lighthouse. So as I said, for the Mobility Lighthouse, we are looking at mobility applications, and classically, of course, then if we talk about the value chain, we would be talking about the automotive value chain, shown here from the level of ECS to the application, and that classically would have been the car. And for the automotive value chain, we have in Europe, of course, a very traditional and strong automotive industry, which is, however, now seeing a lot of radical changes that have been discussed already at length throughout the Efecs conference these past 2 days. And that's why these changes, which I'll get into in a moment, have of course engendered several effects, consequences for the automotive field. And that is also a reason why we talk for the Mobility Lighthouse not any longer only about the automotive as the end application, but the full range of mobility solutions that are on offer. Electrification and automation are, of course, longer lasting trends, and that have shaped this field, this area. And these have been then joined over the last year by the effect of the COVID pandemic with ensuing changes, as well as, of course, a stronger societal focus on green solutions and the importance of the climate change. To highlight one of the more recent changes then, I'd like to show here a result from the report of UITP and RCD Little with an early analysis of potential effects of the COVID pandemic and the lockdowns, of course, that were and are still being implemented to control the pandemic. Yeah, in the very first weeks and months of lockdowns, we saw an increase in motor vehicle use and a decrease in the use of public transport. While we also have to respect, of course, that initially with a strong lockdown, all modes of transportation went down, but we see then that as lockdowns were eased, or in China, from China, we see reports where lockdown is no longer necessary due to the positive run of the pandemic there, that in fact, longer, mid or long-term effects are expected to increase the use of individual mobility, motor vehicles, and unfortunately, probably also the use of public transport, while new transport modes, electric scooters, as well as classical bicycling and electrical cycling, can see a long-term increase in usage. There are then other effects, looking not exclusively at mobility, but of course, an increase in home office work has seen cities, or the way people travel through cities, become more multipolar. So while we had rural and pendular cities already before, multipolar cities are becoming a reality increasingly, and accordingly, we need suitable mobility solutions that should be provided. Another trend I would like to highlight is the need to look at the mobility system as a system of smaller system units. So we see on the left-hand side here the vehicle, where we already have a combination of very many components, where a systemic approach and perspective is already required. And on the right-hand side, looking then at the entire system, vehicles coming together, the need to coordinate them, of course, a need for connectivity and coordination of individual transport modes.
Streaming doesn't. Maybe just see the agenda.
Oh, just been informed that my slide has not been forwarded since the first slide, so I will try a moment to fix that, because seeing this is not going to be very formative. So let me try again to start beginning. Is it changing now? Info if it's working. will try again. Seem to have worked. Perhaps it will work this way. Okay, I hope the slides are visible now. And I will try to show the ones that I already have been talking over in a quick summary at least. Okay, so yes, this slide was to illustrate the starting point, the classical automotive value chain with the automotive application at the end of the value chain. On this slide, I had shown some changes that this value chain has undergone over the past few years, and particularly, of course, those introduced by increasing levels of electrification and automation. Then, to discuss the COVID effects, this was the effects on different modes of transportation, where, as I was saying, the long-term effects are expected to be what we can learn, what we can see from China thus far, that the use of individual cars will increase. Public transport will probably also in the long term see a reduced usage, but new transport modes such as electric scooters have increased, and this can also have a long-lasting effect, while cycling has also increased in usage. And on the lower half of this slide, the point I was making about multipolar cities becoming a reality increasingly, given the increase in home office work. And this to highlight the aspect of the need to look at the mobility system as an entire system. And if we talk, for example, about the efficiency, looking again at the implications of the Green Deal, then a systemic view is required to really gain as much efficiency as possible. So if we look now back again, starting from the more classical automotive value chain, the car at the end, then we have, shown here on this slide, just need to shift something here, sorry. The classical application here shown already for an electrified car with classical components that has been joined now on the application end, upper side of this graph, by new modes of transportation. For example, fleets of automated vehicles, connected vehicles, on-demand shuttles, but also not limited to road transport, drones or delivery robots, also new potential applications that need to be provided on the ECS side with new components, giving the required levels of connectivity, cybersecurity, for example, or allowing the necessary extent of data processing for AI applications. Furthermore, we have, and this is shown above the graph here, not only the technical aspects to consider, but increasingly also non-technical aspects, economic, legal, and human factors, as well as societal factors, where we see, for example, now with the COVID pandemic or the implications of the Green Deal, how priorities shifting within society also have direct effects on the mobility value chain. And there are, of course, then push and pull factors, elements between these two ends shown here of the mobility value chain. For example, new applications requiring new components from the ECS side. Still having some minor issues with the presentation, but I hope it's visible for everybody now. And this is where the Mobility Lighthouse comes in. This new and increasingly complex and diverse ecosystem of mobility solutions needs to be connected in some form. And the Mobility Lighthouse is there to provide the networking and collaboration platform where all stakeholders along this value chain, but also stakeholders from the non-technical fields can come together to discuss research priorities, for example, or actions that should be undertaken to accelerate the implementations of these mobility solutions that can answer some of the societal challenges that we're facing. And as I mentioned at the beginning, the COSMOS project is there as a CSA to drive the Mobility Lighthouse. It is being carried out by the project partners shown in blue on the map here and supported by the associated partners in the green boxes on the map, and really works to analyze the mobility ecosystem to identify research priorities and gaps perhaps in strategies, to check project work and strategic documents for coherency, and in particular to support exchange and collaboration between the stakeholders of this ecosystem. The Lighthouse is further supported by an advisory service composed in part of also contributors to the COSMOS project, but even more stakeholders, and as you can see here, from very diverse organizations covering the entire mobility value chain. I will have to make up for some lost time due to the presentation issues. I won't go into too many details, therefore, on these Lighthouse projects, which are also an important part of the Lighthouse, because this is where direct exchange can take place between different projects. Also projects that have already ended can present their best practices, but also these projects can have joint dissemination activities. And one of those being their presentation as part of the Efecs conference yesterday and today. And that's why, for further information on these projects, I would like to point to the Mobility Lighthouse booth accessible, where further information on each of these projects can be found. The time that remains, I would like to use to highlight two activities of the Mobility Lighthouse as supported by the COSMOS project from the two components of the project, which are strategy development and network support. For the network support, first of all, just as an example, we have every year the ECA 2030 conference, where you can see the program of this year's conference, which has already taken place a month ago. But just to show what kind of elements you can expect from an ECA 2030 conference, where we have keynote presentations from stakeholders, again, along the mobility value chain. We have keynotes on urgent priorities that need to be addressed. This year it was decarbonization, validation, and connectivity, but also panels to get the conversation started. And again, this year's example on the connection of European partnerships was one panel, and another example would be the comparison of European and national research priorities, for which we also had a panel. But an important aspect or part of those events are always exchange with a wide and diverse stakeholder circle, and that's why we always have an interactive element in the ECA 2030 conferences, and we also will have one later today in the afternoon at 3:30 with an interactive session on research priorities and actions. And here I can also provide first insight. This is from the strategy development part of the project, where we started originally with 7 urgent priorities shown here, and have refined those on the one hand by the selection of the Lighthouse projects, highlighting these 5 urgent priorities shown here in their distribution, but also in surveys at events and now increasingly online. And here I would like to show, and as I just mentioned, there will be further opportunity for discussion of these priorities and the actions that follow from them in the afternoon. But just to give an idea, this was the result of a workshop at the end of last year with priorities, subtopics for each of the 7 urgent priorities. And if we look then at the result of this year's workshop, last months. We see the topics here in green that have been added in this step designed to validate the completeness of the research priorities as well. And we see here also one of the trends clearly in these new research priorities, which is the need to look at the entire mobility system, where we see under connectivity a new priority to have a continuum and redundant network, but also in decarbonization, this idea of the importance of achieving extrinsic energy efficiency by system integration. Yes, and with that, I have reached the end of my presentation, and I would like to point you to the Mobility EU website on one hand, which you can see here. It's mobility.eu, and amongst other things, you will find there information about the Lighthouse projects, Lighthouse activities, and an opportunity to complete a survey on research priorities. And as I mentioned, this afternoon, starting at 3:30, we will have an interactive workshop started with a keynote also on a particular research priority in the field of validation, and then the majority of the workshop dedicated to verifying and adding to the research priorities, but also defining actions that should be taken or can be taken to accelerate the implementation deployment of electric, connected, and automated mobility solutions. And finally, the Mobility Lighthouse virtual booth will also be available for the rest of today. So with that, sorry for the technical difficulties, and thank you for your attention. And also, if you want to get in touch, then write us an email at contact@mobility.eu. Thank you. Thank you.
Thank you very much, Benjamin, for the interesting talk. I'm afraid we don't have enough time for a question, so I would just straight go forward to our next presenters. However, I also want to stress that if there's any further need for discussion and any further interest in the Mobility Lighthouse and its activities, please join the co-located workshop in the afternoon. So now I would like to give the floor to Michael Paulweber from AVL List and Patrick Piepe from NXP Semiconductors to present the Srq Mobility Chapter. Mr. Paulweber was appointed Director of Global Research and Technology Management in the AVL Instrumentation and Test System Division in 2012. He became Head of Development for the Test System Automation and Control Production Line at EVL List, and he gained expert knowledge in embedded software development. Michael serves as a Vice President for the European Industry Association ARTEMIS and as a Vice Chairman of the ECSEL Austria. He also serves as a member of the European ECSEL Steering Board. And finally, he holds lectures at the University of Applied Science as well as at the University of Technology in Graz. And I will also just give a brief introduction to the other speaker of this presentation, Patrick. Patrick is the Director of Strategic Partnerships at NXP Semiconductors, also since 2012. He is running the Srq Project on security of autonomous systems with a big consortium of 69 partners from 12 countries throughout Europe. Patrick is chairman of the Penta Technical Expert Group since 2018, and he's also a member of the ARTEMIS Steering Board since 2015, and of the ARTEMIS Presidium since 2018. He's furthermore co-chair of the overall ECSEL Strategic Research Agenda and is also co-chair of the chapter on transport and mobility. So please, Michael and Patrick, we are looking forward to hear your presentation.
Thank you, Caroline.
Okay,
thank you, Caroline. I will take a start and then Michael will take over. So if you can see the next slide, please. So in fact, what we have done is we have been looking at what is the 2050 vision towards mobility in order to guide the developments which are needed in Europe in the domain of electronic components and systems. So the first one is about the Green Deal, where we are currently working on a 37.5% reduction of CO2 in 2030 compared to 2021, and where we want to strive for a net zero CO2 emission in 2050. Second topic is road safety, where we want to go for a zero road fatalities and accidents scenario in 2050. Important is also inclusive mobility, so 90% reach of the people with special needs, where as of today only 60% of the people with special needs are included in the mobility domain. And of course, last but not least, is to keep us competitive in Europe with the rest of the world and to keep technological leadership throughout the value chain in the mobility domain. Next slide, please. So we are currently on our way to improve for society, and I've just taken one example, which is the zero accident scenario. If we look at manual driven cars today and we look at worldwide figures, we see that there are more than 1 million road fatalities annually. There is one accident every 23 seconds in the world. Also in Germany, we are 3,275 road fatalities in Germany in 2018, already much better than the 20,000 in 1970, but still too much. Major causes of these are human errors. And of course, we would like to evolve towards autonomous driving in the future. And if we look to the autonomous accidents to date, there were 14 serious car crashes with autonomous cars and 6 fatalities. And the major causes today are inferior sensing systems and human behavior outside of the vehicle. And that's why we need to work on future systems and improvements on this sensor environments and these controllers to make sure that the cars catch everything that is happening in the world. So please, next slide. So in terms of leadership and driving innovation in Europe, I think we can be proud to say that in the semiconductors field, we have 3 European key players, NXP, Infineon and STMicroelectronics, which are in the top 5 worldwide in terms of semiconductor sales, and together count for $11.5 billion in 2018. Second point, in Europe, we are very strong in our evolution towards autonomous driving and connected cars, which is a real booming market. If you look at the European gross domestic product growth, this is average 2 to 3% per annum. Whereas if you look to car safety applications, autonomous driving and connected services, they are growing respectively with 28, 31 and 15%. So it's an area where we are strong and where we should keep strong in further making technological progress and innovation. What is also important is that we see that the automotive developments are often also driving innovation in other domains. A lot of developments which are happening in the semiconductors and software for autonomous cars is also used currently in industry, in energy, in battery management systems, in the health sector, in agri-food, in digital life and digital industry. So here I would like to also emphasize the synergy with other public-private partnerships. So we are currently involved in KDT, Key Digital Technologies, where we are working on the building blocks, the electronic components, hardware, software, electronic subsystems, which are then used throughout the value chain towards the end application, towards the OEMs, and which are integrated in the products for end users like cars, bicycles, etc. And there are 2 other public-private partnerships, CCAM, which is Cooperative and Connected Automated Mobility, and we have 2.0, the first one taking care of really autonomous cars from a system perspective, from the car perspective, 2.0 taking care of zero emission and CO2 reduction, and KDT making sure that the electronic components and systems are available. And you see also the synergies with the other domains where we are working together with quite intensively. And here I would like to conclude my part of the presentation and give the floor to Michael Pollweber for the remaining part.
Thanks, Patrick. So I hope you can hear me. I want to go now into a little more detail about the different challenges. The first challenge is very much in sync with the European Green Deal. Electronic components and systems are the basic building blocks required for electrification and sustainable alternative fuels for a CO2 neutral mobility. If you look to the graphic below, which I've taken from IHS, which indicates that the prediction is that in 2030, which is not too far from now, more than 60% of the vehicles sold will be electric or electrified vehicles, which means that we have to ensure that we can provide this electronic and software building blocks which enables this transfer to this CO2 neutral mobility. We have a more detailed roadmaps, which I just show as an indication, but won't go into all the details, where we have identified different goals which we have to achieve, shown in this roadmap on the slide on the right-hand side. We do not consider this CO2 neutral mobility only on passenger cars and on goods transport, but we want to extend that also in what we call CO2 neutral light mobility. Light mobility, we think these are bikes, tricycles, wheelchairs, drones, agricultural devices, and there are many more which also contribute to the current CO2 because they most are driven by combustion engines and they also have to be converted to electrified and partially automated vehicles. The roadmap itself indicates that we have the light mobility, either electrified or in some cases where you need long durations, for example, for drones which fly over the sea for many hours. Then also fuel cell based mobility has to be supported by our sensor components, by our components which contribute, which use AI on the edge, controlling this, figuring out what the environment is and find out what's the best way to have the minimum usage of energy. Third challenge goes into the goal for this zero accident vision, where we want to enable affordable, automated and connected mobility. It also shall contribute to the inclusive mobility because our society gets elder and elder. Also, the census from our citizens, they do not stay that advanced over the lifetime, so we have to support them with figuring out what's going on and taking care of the safety of our citizens. Automation in mobility is a very complex system and it requires our components at very many different places. It starts from the sensors, which more or less can convert what's going on the environment into some electrical signals, which then have to be converted using mainly a lot of artificial intelligence, edge computing, into a perception, so that we have a good understanding of what's going on in the environment. Then we have to communicate to the outside world to figure out what is doing the traffic and all the others. We have to know where a vehicle, a truck, a drone should go and convert it into a control strategy from path planning, behavioral planning, motion planning, and then convert it into, again, mostly electronic components where we influence steering, braking, accelerating, decelerating. In addition, we have also to communicate to a lot of other electronic systems like adaptive suspension systems or battery systems or powering systems, whatever it is. The third challenge is very much related to the third challenge, which means we have to ensure that these systems can cope with any situations out there in a safe and secure manner, and in parallel also taking care of the comfort of now the passengers, because also the driver in such a case gets a passenger. So we have to deal with validation and with certification. It's common understanding that such a certification and such a validation cannot be done just on the road. You have to combine virtual versions of these automated systems, virtual versions of the traffic, of the environment, together with real components. And for this, also again, a roadmap is there where we are currently actively working in, heavily working in level 2 plus level 4, which will continue to validation certification for level 5 systems, and also of the integrated mobility or the extrinsic mobility, as Rainer stated. Which leads us to challenge 5, which is extending the mobility not just to the different means to go from point A to point B, vehicles, trucks, ships, airplanes, but to take into account 2 other dimensions. The one which is the multimodal mobility, so that you have different best energy optimals way how you go from point A to point B. And the second, you take into account all the rest of the traffic in cities, countries, interstates, roads, which leads us to an extrinsic energy optimum, which we have to fulfill, where we have now to take advantage and combine edge computing with cloud computing, with a lot of communication, for which we have to provide the components, the software infrastructure, the software pieces for urban and long distance energy, optimal mobility systems for rural, as well as for a global energy optimization. All of it we have put into a timeline. The timeline, as already presented by Benjamin, is split into 3 parts: our short-term goals, the mid-term goals, and the long-term goals. We have just visualized some of them. You find them into way more detail in the new version of the Strategic Research and Innovation Agenda. Okay, that's the overview about our content in the mobility chapter.
Thank you very much, Patrick and Michael. Unfortunately, it looks like there are no questions, but then I will go on and ask a question. So I will start with Patrick. Maybe you were showing at the beginning that the EU competitiveness is obviously a very important factor to take into account. So my question would be if there are already some specific concrete actions or ideas how to further push the EU competitiveness.
Well, I think it's, I would say, a continuous battle to win the innovation, to make sure that you are a market leader in certain domains and that you keep the market leadership. So it's not a matter of special programs or whatever. I think it's industry who has to stay competitive. It's universities and research institutes which have to be closely connected to what the industry is aiming at and the roadmaps being built in industry. And if you are working together very closely between industry, universities, research institutes, we can make sure that we win the right battle, so to speak, and that we stay a market leader in the domains we're strong in. And my advice is really, let's make sure we get stronger in the areas we have already a certain strength instead of trying to fight a lost battle, and make sure that the domains we're currently in, we stay market leader in.
Okay, yeah, thank you very much. So maybe one more question to Michael. We heard before already also in the Mobility Lighthouse presentation that the importance of cross-sector collaboration, and that we should not just stay within our one sector, and also the need for horizontal connections. So my question would be, this chapter that you were presenting is obviously now all about mobility, and it's also already broadened from, I would say, an automotive perspective to a mobility perspective. But what are the opportunities to further also transfer solutions from the mobility sector to other sectors? For example, health, agriculture, or robotics?
Yeah, Caroline, thanks for the question. It's a really interesting question, and throughout the work on our chapter, we spend a lot of effort to get in contact with other communities, like with the ERTRAG, the ECI community, but also with hydrogen and fuel cell, with battery communities, with IoT community, because KDD is just providing the building blocks for the products we're working on. Mobility systems, whether it's a plane, a ship, a drone, a car, a truck, requires more than just the electronics and the software. It requires wheels, seats, a chassis, and so on, in order to really provide something which is useful for the society. So we have to work in close contact. And if you take it as if you consider that we are moving into more autonomous systems, then all of a sudden there's a lot of time available for the passengers, which then pose lots of additional opportunities. For example, in the health area, that you can add other sensors to the systems, which in future maybe can do what currently is going on in a lot of different countries, where they want to do COVID checks for more or less a big portion of the population. Maybe we can think about systems that in future you do it while going from point A to point B. It's done automatically without any annoyance to the passengers. And there are lots of other ideas around where we can combine now these different domains using the advances in our controlling electronic components and systems, the sensors, edge computing, new control algorithms, new software advances. I hope that answers your question.
Yeah, this answers my question. Thank you very much. We actually got now one last question from the audience, and I will just go ahead, and whoever of you feels most addressed with the question, please answer it. So one question was, would you comment on how do you see synergies with other partnerships, and would cloud or smart networks be relevant?
So if I can answer, for sure, there are lots of synergies because of the fact that we consider three things. We consider the individual, the control in cars, ships, and so on. But we have also to consider the traffic around and influencing how the different traffic participants, vehicles, e-bikes, whatever, take advantage of the precious good of road space and time on the road, we can save another significant portion of energy. So this extrinsic optimization we can do only if we also communicate and heavily interact, for example, with the people in cloud computing. And another aspect where cloud computing can help you, that in cloud computing you can share a huge amount of data where more or less you have the information about the history, and from the history you can predict, for example, how the traffic will be in the future, taking into account weather conditions, time of day, time of season, and so on, which you can then use to find optimal strategies for individual vehicles, but also to interact with the other vehicles and then find the most energy efficient way how to transport people, goods in the world.
Yeah, thank you very much.
Shortly add to this, I think indeed, if you look at future mobility elements like cars, bicycles, trains, they are part of a bigger network. And if you look also at the developments, we see more and more that, for example, companies active in the 5G domain are working together with companies active in the automotive domain to ensure to build some reconfigurable communications and radar stations, for example, in the future. So the different worlds are indeed merging together, and everyone can learn from everyone. And I think mobility is a very, I would say, a key innovation area where, in fact, the connection within the cloud, within the network, can stimulate further innovations.
Yeah, thank you very much. And thank you very much for the presentation and for these insights. So with this, I would like to go on with the next speaker, Rainer John from Infineon. Rainer received his diploma degree in electrical engineering from the Fachhochschule in Saarland in collaboration with the University of Metz in France. In 1984, he started his career with the Siemens Semiconductor Group in Munich, where he worked in the field of automatic test system development. And this was followed by different other positions within the Siemens Group. In 1996, he joined the Siemens Semiconductors, the later IPO of Infineon Technologies, where he's still part of the company. In the year 2000, he further pursued his career in Taiwan, where he set up and managed the Infineon Silicon Foundry Taiwan office as the head of department for 7 years. And at the present, right now, Rainer is in charge of the coordination of publicly funded research and development projects in the area of trustable AI for industrial and mobility applications, and also in the inspiration and management of research and development projects, mainly for electric mobility based on highly efficient propulsion, perception, and advanced control systems. So, Rainer, please.
Very good. So thank you very much for inviting me and to give the opportunity to talk about the electric, connected, automated, and shared mobility. And what does it mean? Convenient, affordable, and safe to the destination. And on the other way, we had a lot of discussion about shared. Shared means maybe values and information sharing. It means not directly to share a seat in a car. It means to take a look on the overall system. And there are some obstacles. When emissions needs to be reduced faster, when mobility service needs to be more personal, more effective, not more cars in the city, this is not anymore an option. Transportation capacity is limited for people and goods. Infrastructure development is limited. So we all know these obstacles when it comes to a new street, to changing the infrastructure in the city. Traffic jam is created everywhere, even not by appropriate system knowledge. And mobility is not reaching the social optimum. So we need a tremendous different view on mobility. And we need to transform it faster. For that, we need an exponential growth element. And this is something I would like to explain a little bit. This is consumption benefits of silicon carbide, MOSFETs versus silicon IGBTs. This is a courtesy of Mercedes. And what you see here is the inverter is giving us the opportunity, so the electrical system is giving us the opportunity to reduce the power consumption. But what you see, the power train and with or out the inverter is very stable. 28 watt per kilometers, and if you look at the real drive, it's 32. The basic consumption is 100 compared with 157. And if you look at the 400 volt powertrain, we get roughly about something 6.9%, 7%, the silicon carbide 7.7%. And even in the real drive, it's also something like a few percent. What is now the options, or what is the question behind? What means intrinsically getting better? Intrinsically getting better is reducing this. This is what we tried over the years. So we get better and better, and we build more compact systems, more compact electronics, more compact inverters. But the basic consumptions, the majority keep same. So, and the chances, if you compare the consumption with the VLTP cycle, with the real drive, we have a huge opportunity there. If we improve the driving and the behavior and the traffic itself, this is what I would like to call extrinsic efficiency. We have big chance. And to take in a system, if we can explain everything, it's kind of a reduction. And this ends, and this course shows it's explainable by its components. And if you look in traffic system, maybe they are not explainable anymore. I like to show the example of intrinsic and extrinsic efficiency if you look into complex and complicated system. Here we have an example. So there are ants, the ants build a bridge, they bring the food home, and the individual ant does not know anything about the bridge. The collaborative individuum knows nothing about the bridge, and we see bridges on the right-hand side. We see a lot of traffic there, but nothing happens. Only if we change to share the information there, this is the topic I would like to highlight, is the chance to get a better result overall, not the single ant which brings a leaf home or a piece of the leaf home. To harvest the leaves, this is what needs the collaboration. Trustful collaboration in complex and complicated systems is that what gives us emergence. Emergence is something which happens, which is more than the individual parts together. Another example for this is bringing a big piece of food home, 3 ants. The topic behind is sharing information. So none of the ants knows what is needed to transport, but altogether they solve a very complex problem. And it's kind of swarming. It's not anymore intrinsic, it's extrinsic. It's working together, collaboration, and exchanging information. This is what we see today, or what we expect, our way to accelerate the CO2 neutrality. We discussed 2050. Can we do it? Maybe not. Maybe not, too slow. Maybe not fast enough. So we would need an exponential driver, which gives us the opportunity to get this early majority and the late majority faster in the car, in the collected and the automated mobility. And what you see here is shorten the time. How can we shorten the time? So we need to make it more steep. We need to move this angular height. But how can we do this? The question is very simple. exponential growth and exponential growth is digitalization. It's a very simple idea. If you share the information with others, the information becomes more valuable. So that means you do it in a virtual world. You put the information you have together, you share it, and then the simple thing, I just used here an IoT device is from errors, which says you get information, you have a real-time AI intelligence, you build a swarm, and then the mission is yourself. And out of this independent systems, we have an organization, and the organization on the availability of a non-equilibrium will help us to build a system we understand better. We share the information, we get the information, we do better and faster automatization. We have a vehicle, but the vehicle on its own is not the key. Even the city on its own is not the key. What we need is bring person and goods to the place where we want it. We have public transportation vehicles. We have the energy domain. We have emissions, things to consider. But in the city and on the car, we need the edge computing, edge-to-edge computing. We need the cloud, we need the connectivity, and we need the virtualization. So that means to bring these systems together, we need in the shared mobility, the connectivity, sharing the information, sharing and getting back faster to the car itself, interacting with the urban environment. And this will reduce the CO2 footprint for the infrastructure and the energy domain. There's a huge potential. Not anymore in the inverter itself. For sure, we need to develop further inverters, make it standardized, make it more affordable, make it smaller. There's always a way behind. But the point we need to understand the semantic layer for the ECAS, electric, connected, automated, and shared, and the future. We would like to have the decarbonization, but we need to do it with the digitalization to get the exponential growth, to get it faster introduced. Electrification, standardization, automatization is what we did. What we need to do is understand the system now to improve the footprint, the infrastructure, together with the energy domain. Therefore, we need connectivity, V2X, V2 everywhere. We need the edge cloud connectivity. More errors, more connections, more interdependencies or dependency on it. Intrinsic, extrinsic efficiency, we discussed it. So this is something we need to do. We don't need to think anymore too much about what is to improve in the car itself. This will bring us cost, this is fine, but usability and services. And the way to the services is not what we need. From some percentage to 20 to 30% overall, and for penetration of maybe 50% of electric connected and automated shares in 2030 on the way to the decarbonization in 2050, this will be a huge step ahead. So the interaction between service affordability and usability with the efficiency is the key. And how to do this? So that means we discuss climate neutrality, zero pollution, sustainable transport, transition to a circular economy. We have the ECSEL MASP, we have many things we discussed. But how to bring the system together, to bring the car on the lower end of our discussion. The vehicle is an IoT, a system-on-system device, as simple as we see it. Platform for mobility, for sharing data, control, and computing resources, functional architecture, built on functional architectures and integration, and with the properties of green propulsion, dependable perception, intelligent platforms, and intelligent components. And I put AI in. AI is what we do in the machines. then we are able to bring it together. This find the way, mobility as a service, in the digitalization, in the digital economy, forwarding to the Green Deal with all the things we need there as a social optimum, even as a growth function for application services and business models. So the car with electric, connected, automated, autonomous and shared capabilities become the key in the mobility to fulfill the digital economy and the Green Deal. So this was our old enjoy life with less emissions through electric mobility. And now the new idea, and what we show also in our Lighthouse Mobility.E, is enjoy life and more efficient traffic to electric, connected, autonomous and shared mobility. So that's all. Start to think about it, start to discuss it, and I would be very happy if you challenge us with your questions, with your ideas, and even if you say that's all nonsense, please let us know. That's very important. Thank you.
Thank you very much, Rainer. There are actually no questions, but there's a comment that I kind of would like to transfer into a question from the audience. The comment is mass mobility is moving back from public to private transportation due to the pandemics. So, I mean, the main idea of your talk is obviously the systemic approach, and that at the end to have a cleaner, affordable, and yeah, I guess also safe mobility. We need like a shared, integrated. Thank you for that. We need a shared, the shared approach for mobility. So are there any specific ideas how to also approach or to make sure that the sharing concept is not going to, kind of lag behind now with the pandemic?
I think the pandemic the components of a whole system without forgetting the system was the wrong way. So that means a virus, to see a virus without wearing a mask is nonsense. You can discuss virus and no mask, but by the end, you need to do something to get along with the system, with the challenge. So we need to think, put it together, get an idea together. And also the projects, they need a critical mass to think about it. Projects with 2 or 3 partners, maybe only 5 or 6, they can do some very specific thing. But if you go along with a system which needs many different aspects, and even what I like to say is not to understand all the arguments which support my opinion. We need arguments that do not support my opinion. What is wrong with us? What can be challenged? What needs to be changed? And this is the point I like to emphasize on that.
Okay, thank you. Yeah, if you start with saying what needs to be changed and challenged. I mean, you were talking in the presentation about the bigger systemic picture, and also how collaboration and sharing information is the main important things to go ahead. But what I have the feeling normally is that collaboration is relatively easy within the same sector, or also maybe even amongst different technical stakeholders. However, in a bigger mobility picture and in a bigger picture for shared mobility, there are also other stakeholders that need to be included. Of course, the society as a whole, but also, some more economic factors and legal factors need to be addressed. How do you see that it can be effectively done to also bring together those different type of stakeholders in a trustful collaboration.
This is exactly the point you address here. We need to look for the arguments which do not support our opinion, which gives us by the end the social optimum. We are looking for market optimum. That's usually the way value trends do, systems, economical systems do. We need to have a balance between what is possible, what is really beneficial for all of us, and what is beneficial only, and make a trade-off between technical development, social understanding, affordability, and acceptance. So what we have in the Lighthouse is a look on all of this. We have the non-technical requirements. We have the 7 urgent priorities, which are driven by technical understanding, deep dive into the system itself. But now we need to extend really the Lighthouse to something which is a lighthouse looking for all of us. And I guess this is the way we do. And I hope this would give you the answer you are asked for.
Yeah, thank you very much. I agree with you. We definitely should broaden the stakeholder circle. And as you said, this is already the approach from the Mobility Lighthouse, and it will be further focused on that topic. So thank you very much again for your interesting presentation. Then I would like to now welcome Mr. Thomas Kübeck. Mr. Kübeck received the diploma degree from the University of Applied Science Regensburg in 2010 and the Bachelor of Honor in Computing Science from Staffordshire University in the UK in 2010, as well as a PhD in Computing Science from the Staffordshire University in 2018. Since 2013, Thomas is working on topics regarding highly automated driving functions, covering all fields from the vehicle design and setup, software architecture, to the evaluation of highly automated driving systems with BMW. And since 2020, he gives a guest lecture. As a guest lecturer, he gives a lecture for system level verification and validation of automated systems at the Stanford University. And he is also, since August 2020, so just very recently, he is working as a leading architect at the Toyota Research Institute for Automated Vehicles of the Future. So welcome, Thomas, and we are looking forward to your speech.
Hi, first of all, thank you for having me. I hope you can hear me.
Yes, we can hear you.
Yeah, perfect. Today, I would rather give a bit of deep dive to actually show what is actually a problem space right now in the state of the art. So basically, I want to give a small glimpse about my former research in smart infrastructure data and what it can do actually for verification and validation of automated vehicles. And the importance is the vehicles, because as already said, when it's getting to shared and also connected and clever vehicles, everything right now is pretty implemented passively. So we definitely need to have a communication to actually have a proactive traffic space. And so I actually talk about the problem cells itself. So basically, what is a scenario space and what you can actually get out of fleet data or the accuracy of fleet data, then state of the art in simulation, because we often mention it, but what does really simulation contribute to the verification and validation space? A small example and thought use case, and then actually a solution, what is still missing and what also needs a bit of certification, and then more methodology approach, which people should agree on. So I just jump into it regarding times, and hope I don't have too many open questions at the end. So basically, what is a scenario? So the thing is always, everyone realizes that just driving miles is not the key to actually verify, validate a ultimate driving function. So basically what is really important is that you actually can compare and define scenarios. So basically, normally you define a scenario along criticality. So how big is the severity? Is it a fender bend in a traffic jam, or is it really severe to the occupant if something happens in that situation? The complexity, the right picture is one nice freeway drive is not the same as driving through a construction site. And the occurrence probability, so how often actually happens that? And for example, if we drive to work in the morning, we actually enter the freeway, we merged into the traffic, we maybe have a cut-in scenario, maybe we want to overtake, and then we also actually go into a construction site or drive through a construction site. So the important thing of that is all of those are mainly different requirements, and then depending on the level of automation, you want to handle those or not, or even you want to detect it to actually give it back to the driver. So you still need to detect it. That is your system boundary in that area. So and that's pretty interesting. And as you look at the seconds, this is pretty representative first, because when you look at, for example, cut-in scenarios, we have seen a median cut-in takes about 7 seconds right now. We have seen sigma 3 in up to 14 seconds. So everything happens right now in this requirement domain in around maximum 30 seconds. And then you can rate it, and this way you can actually build up your traffic space and you can analyze your system at the end. So you get a real safety case for your evaluation methodology. The thing is now, a lot of people are driving around their field operational tests. So this is basically, it's complicated having a 2D representation of a scenario space. Let's say this is the representation what you get when you have a test driver out in the field. So hopefully no OEM has ever crashed. We have seen some, but normally they are well trained, and you don't see critical scenarios. And the problem is you not only see those critical scenarios, as you have the sensors on top of your car, they have sensor noises. You don't see the real situation. So if you post-process it, you still need to somehow extract the ground truth of that data. Not only that, as already mentioned, so basically if a test driver is driving through a construction site, he might drive on the most right-hand side of the construction site, and this way people are overtaking. So if I'm a really bad driver and I drive sinus curves in a construction site, maybe everyone is afraid of not overtaking me. So basically, you might never see an overtaking maneuver depending on the driving behavior. So to emphasize that, human driving behavior is a lot different than actually you are driving around in specific scenarios. It's the same if you can drive L4 in Munich, doesn't mean that you can drive L4 in San Francisco or in Shanghai or anywhere else, because the dynamic driving patterns are different. On top of that, if you actually introduce automated systems, you actually make up a new space of scenarios, because automated systems basically normally drive really defensive and reactive. And that means that looking at the scenario distribution, for example, if you have always the same cut-in maneuver, then you have one which is representative, a normal cut-in, what you most of the time see, and then one really slow, long cut-in and maybe some cut-offs. They're really short. When you drive around with your test driver, you only see a small portion of that density function. And the thing is, normally you have a shift in that density function. If you drive more defensive, you have longer time headways and you have longer time to collisions, and that actually shifts the traffic space a bit. And that's somehow we actually want to find out. That is the equation we want to somehow generate. But the problem is it's a prediction how the traffic will be, and that's normally only effective analysis is only possible when we actually invest more into simulation. And there is the problem, because starting with automated driving, it's only possible in micro simulations, combining to a macro simulation. So talking about contribution of simulation, ideally, yes, we see something in the real world, and then we say, okay, we extract the scenarios and then we resimulate it. Then we have some KPIs, time to collision, time to react, and everything we have on a system level side. And then we derive those KPIs basically, and then we can compare them. The problem is simulation is not always representing the real world. That's the main problem. For example, low-level sensor fusion is always complex. Everyone knows that. We only can have a small portion reproduced in our simulation environments. And therefore a small thought space. So basically what we have done, we actually did a lot of scenarios and we recorded them on a test track. So SD stands for sensor data. So it's the object list and these kind of things, the dynamics that the car actually seen. So actually we recorded the situation, red is the sensor data, green is the ground truth data, and blue is my ego vehicle. So we did a KPI evaluation, let's say it's a 7 from a scale from 0 to 10, and 10 is really good. So it's reasonable. So the system itself thinks, yeah, I can still handle it, small deceleration, done. So, but we looked then what really happened and we analyzed the green ground truth data. And we have seen that it was a lot more critical because the failure was basically in the object prediction. And it was more critical as the car actually has seen it. So what I've done is next is we took the sensor data, generated a scenario, resimulated, and did a KPI evaluation. So what happened was super surprising. It's a 9. So we thought, okay, we should do the same with the ground truth. So we extracted the sensor out of the ground truth data scenario. Then we simulated again. And at the end, we again had a 9. And basically that showed when you look at the data, green is the ground truth of the first run. You see that it was pretty critical from a time to react basis, what we introduced there. And the sensor data, so the car itself doesn't estimate that it's so crazy. The thing was what now happened, because we haven't had perception models, the sensor data and the resimulated ground truth data both is the noise of the simulation, because the simulation has also the timing issues, and depending on how your system is being set up, you have a small noise. But what you already see is the shift of 7 seconds to 6.5 seconds. And that is the first indicator that actually the system, because of no perception models, has seen the scenario earlier, the cut-in scenario, and therefore could react earlier. And that's something we also see in the data at the end. When you see the green line, this is the ground truth line, and the red one is the one which our car predicted. And when you see actually the most of the noise you normally get in those automated vehicles in your perception, when you actually try to estimate the state, the future dynamics of the other car, for example, because that is where you actually use, okay, easily speaking, a Kalman filter or a non-linear abbreviation of what is happening right now. So the world is throwing you a lot of non-linearity to your car, and kind of people are cutting in, and you actually linearize it in your state estimator. And that actually brings that overshoot and the undershoot. So you see basically in the turn, we overestimate, so we think the car is still going straight and forward. And then when it cuts in and it's linear, the filter actually aligns again to the curve. And then again, at the second 7 to 8, we already still have a high noise in the system. The interesting portion is now when we actually generated the scenario, which is this light red, we see already that when we extract the scenario, we already have more a ground truth signal, because we actually do a interpolation through the position and we extract the velocities out of it. So we increase the signal again. And that's something which really needs to be standardized as well if we want to compare scenarios between different OEMs or tier ones, or how we want to do it. So the same thing is actually, we see here really nice at second 4, when we look at the dashed ones, which is the resimulated ones, that we a lot earlier see the reaction of the cars, and we see the scenario a lot earlier in simulation, and therefore we actually react a lot earlier. And basically we really change the situation there. We actually, when you look at the heading, we overtake instead of actually just decelerate, because overtaking in this portion is a more safe maneuver than actually decelerating. So we had one of those edge cases where the simulation really changed the scenario category, which is really interesting. So that actually shows the need for perception agent models for simulation. The perception model was clear here because we had actually the noise in our, so we had the ground truth sensor models in our simulation, and therefore we need representative noise to actually do also a really good reproduction of a scenario in our simulation environment. Important is the perception model. I get to that later because that is a lot easier to derive than a sensor model. So what do I mean by that? Agent and perception modeling for increased simulation. What could be a possible methodology for it? So ideally, yeah, we leverage our smart infrastructure data. So I think everyone knows the drone data set, which is not that highly accurate, and you only have a specific environment observability in sense of how long the drone can hover above a freeway, and then you still have, due to the camera and the problem of the distance of your drone, the inaccuracies of your ground truth data, because that's what you actually want to generate. For example, with our setup here, the merge, we got a accuracy of 30 centimeter in position accuracy, 0.1 in meter per second, and 0.1 in degree heading. That means we are at around differential GNSS grade of ground truth data of infrastructure data, which is a reasonable, good range where you can actually derive a lot of different perception models or agent models. So I get a bit more into the detail there. For example, we have physical models. So they actually try to model physical effects. They have, for example, with ray tracing for LiDAR, or you do electro wave propagation with ray tracing as well. Therefore, you need a lot of high fidelity simulation environments, what we don't have, and it's still a research part for the next 5 to 10 years. And simulating low performance, for example, in rain for LiDAR with glass and everything, it's pretty complicated, which is the same for phenomenological models. So basically, this is just multiple phenomena have impact onto your system. For example, you have rain plus a window, or rain and you drive outside a tunnel, or light and you drive outside a tunnel. And that is, or you light outside tunnel and into rain. That would be the craziest one. And therefore, it's the same like physical models. For phenomenological models, normally you need also a good quality of physical modeling. Then we would have statistical models. That's just simply input-output, but as we have seen, that wouldn't have the right impact for non-linearity in your systems. And we have seen the simple models is actually not representative. So we introduced something which is a maneuver-based statistical model. So we really cut out of those scenarios the maneuvers and train basically in an imitation learning approach the sensor models. And why I'm saying that, we published all of this because I think this method really needs to standardize. If, for example, one OEM is extracting data and gives the scenario to someone else, says this is the ground truth data, or plus a variance, how you have seen it, and then you want to actually have your maneuver-based statistical model to actually drive that scenario as well and see if your system can cope it. And this way you would have a cumulative scenario-based approach over multiple OEMs, tier ones, whoever is in that field. So how that works is as described, we have measurements, we extract the ground truth data, and as we have the sensor data of the car, we can actually train between ground truth data and sensor data and the perception model along the maneuvers. In the next step, we can actually use the scenario, integrate the perception model, and do the resimulation. The importance here is that the scenario is the base for a perception model, because normally you want to have pre-calculations that the simulation is actually knowing what happens in the future. You need to somehow derive those dynamics. So it's good that we actually covered the sensor model space, but it's the same still. How do you get actually from the human traffic space to human traffic space plus our system? And that is something which is still a bit missing. We actually need to derive agent data for our simulation, or train agents which actually represent the real traffic data. And why we found that actually infrastructure data is so good, because actually you get a lot of trajectories from not highly automated driving test vehicles. So you get really the traffic of the human driving behavior at a specific place. So you can really derive with analytics, how do people cut in, how do people merge. So you have no traffic influence of your car. You have a efficient data collection because you look at merges or you look at the edge cases. You have a really high improved data accuracy. As said, we have 30 centimeter accuracy in position, 0.1 in velocity, and 0.1 degree in heading. And the good thing is you can also use it for generation of sensor data. For example, if OEM drives through infrastructure and you give him a ground truth snippet of his test drive, then you still can use that to actually help him to derive the necessary models. So basically what we did then for the agent models is we actually did an object detection radar camera fusion. We transformed that and stored the tracks. This is how it actually worked. So we also did the same with our test run to actually analyze how accurate the system is. So we actually drove with our car through it, had a DGPS of our position, and then we detected with our infrastructure our car, and there was also a DGNS module, so we could really derive the error of our measurement unit on, for example, a bridge or wherever you want to actually deploy it. So with then a lot of different methods, I have a few slides in the backup if someone has some detailed questions in there. You can actually do really good imitation learning, and then you can derive agents, and you actually can then run your AD functions in the simulation and do the testing in that area. This is how it actually looks. So you have a lot of scenarios, you add it to your simulator. You have a perception model of your system that's really dependent on your car, on your AD function, on your system setup. So hardware, software config, and these kind of things. And the agent model in that scenario, because you actually want to have a reaction of real traffic behavior if your car is actually, your AD function is behaving differently. And this is how you can actually derive activity analysis, how actually would be a specific freeway snippet included with a black box AD function of OEM 1, B, 2, or 3. Yeah, so sorry for maybe it was a bit fast or not, but I think most of the things are already standard. So scenarios, we have an open scenario, and also the interfaces from simulator to the AD function is done with the open simulator interface. So basically ARTEM is pretty strong in that area, but what is still missing is a common methodology and agree standard for perception modeling and agent modeling, because those are at least a methodology to actually derive same perceptions models to actually simulate, and the agent models are important, that everyone is actually working on the same basis, that we can compare different functions and derive this orange. How do we shift our traffic? Is it getting more safe? Is it getting more traffic jam? Is it getting better? Do we get better TTCs, THVs, which we definitely think we get? So yeah, to answer all the societal impact, what we actually need. So yeah, I think that was the most of it. I still have some backup slides. If we have some time for questions, then I am happy to answer. Thank you.
Thank you very much for the interesting talk. Unfortunately, I think we are not able to have some questions right now because we are directly at the end of our session. However, I would like to shift maybe the discussion also into the afternoon workshop session if there are any additional questions. And with this, I would like to thank all of the speakers for the sharing of your views with us. And obviously, I also want to thank the audience for the attention. And I finally would like to draw again your attention to the co-located workshop of the Mobility Lighthouse this afternoon at 3:30. The workshop will start with the presentation of challenges of engineering safe and secure highly automated vehicles, and then it will be followed by interactive expert consultation on research priorities and research actions to accelerate the deployment of e-car mobility. So I hope to see many of you later at 3:30 in our co-located workshop.
So, dear audience, we are here today and we have been here yesterday to discuss the most important points and key priorities for the electronic components and systems industry, and also with a clear focus on the KDTs, the key digital technologies. And I think what we have learned throughout those 2 days is that in the end, this community can bring a lot that can benefit society as a whole, but also increase the competitiveness and put Europe into a leading position. Well, for me personally, it was very interesting to listen to all those views given by you. So I would like to extend a special thanks to all the speakers, but also to the organization, because without their effort, we could not have pulled off this event. So thanks once again for your wonderful collaboration as well. Well, before I'm going to finally close it off, there are a couple of remarks for you. Well, after this closing remark, there will be a session starting for the co-located workshops. And within the auditorium, ladies and gentlemen, within the plenary session, you'll find a tab on the co-located workshops. You're more than welcome to log in over there. And then finally, a couple of dates were already mentioned. Well, first of all, there's still ample of time until the 14th of December to give input to the ECS Strategic Research and Innovation Agenda. So don't forget about that. Secondly, we would like to invite you also to the brokerage event, which will take place on the 12th and the 13th of January next year. So that's already very soon as well. And finally, ladies and gentlemen, you know, this was a digital event due to the circumstances, but we would like to invite you next year to Amsterdam from the 23rd until the 25th of November, where hopefully, fingers crossed, Efecs will take place physically again, and we would like to welcome you there and to exchange ideas and to network and to discover and to learn. So ladies and gentlemen, thank you so much, and stay safe, stay healthy, and we hope to see each other next time. Thank you.
everyone. Dominic.
Yeah, I think you should go now, Jacques.
Okay. Well, good afternoon. My name is Jacques Magin. I am a senior project manager at Australo-Internov Marketing Labs, and I have the pleasure to welcome all of you to the first CoreNet workshop. We are very glad to have you in our workshop, which is co-located with Efecs 2020, and we hope you will enjoy the next 2 hours in our company. Today, our objective is to exchange with relevant stakeholders from both the electronic components and systems community and the telecommunications community, as well as organizations from complementary domains such as IoT, artificial intelligence, cloud, robotics, and more. We welcome all the people and organizations who are willing to contribute to making Europe the leading player in components for future connectivity systems. Today we have a very exciting agenda. We will start with some initial ideas on the vision and strategy on how to achieve that target, with a presentation followed by a panel with leading experts from both communities. Then our experts will present their initial views on the technical priorities that should be addressed, forming the basis of a European roadmap. You will then, as an audience, have the opportunity to ask questions in the question and answer session that will happen next before we conclude our workshop. So I want to stress that you can ask your question using the chat box anytime you like during this entire workshop. So first, we are going to start with an overview of our CoreNet project, and then we will have a keynote speech. Our first speaker is Dr. Yanning Zhu, who is working as a research and program manager at the Vodafone chair at the Technical University of Dresden. She is in charge of all EU projects and proposals with topics ranging from tactile internet, V2X, remote area network to baseband modem design, 6G and international collaboration, and so on. Yanning holds a master's degree in signal processing and a PhD degree on communications engineering. She leads the consortium and coordinates the operation and work carried out in the project. Yanning, please proceed.
Okay, thank you, Jack, for your introduction. So first of all, can you hear me well?
Oh, yes.
Okay, so I first share my slides here. So can you see slides?
Yes.
Okay, great. And so again, thank you, Jack, for the introduction, and good afternoon, everyone. My name is Yanning Zhu, and I'm a research and program manager at TU Dresden. As Jack has already mentioned, that I'm currently coordinating the CoreNet project and its operation. In the next 10 minutes, I will give you a very brief overview on the project, its motivations, its objectives, and the concept. So let's start with the why question, the motivation of this project. As you probably know, that 5G is one of the most important digital technology of modern times. And Europe is currently very strong at its position with two major network equipment vendors, Ericsson and Nokia, as you see in the left side of the figure, that it accounts more than 30% world market share and more than 50% of 5G contracts so far. But on the other hand, if we look at the right side, we come to the electronic system production. Europe is only accounts for 4% of world production on telecommunications equipment. So we have a situation here, and that the 5G network that is going to deploy in Europe will be heavily rely on the components and subsystems developed from outside Europe. So there's very limited and even no European alternatives here. And so this is a big problem. Why? First of all, if we look at the market size of telecommunication electronics is 400 billion euros. So this is absolutely missing of economic opportunity. And with consideration now we have this very complex geopolitical situation, Europe is very, let's say, vulnerable to any supply chain disruption. Another dimension here is security. And comparing to a previous generation, when we evolution towards 5G, 6G and beyond, it's not just about consumer market anymore. It's about industry. It's about to support critical infrastructure. There will be an enormous amount of data flow in our critical, in the 5G, in 6G and network in general. So if we have no control on the supply chain, there's no say of sovereignty or autonomy. The last point here is that so our future innovation capability and the prospect will also rely on our current capability. If we don't act now, the gap will be just bigger and bigger. Then we come to the question that will Europe maintain its leadership in 6G without the support of microelectronics industry in Europe? So this comes to the motivation of this project. And here is a very general view of this project that is under 5GPP phase 3 program. So it started from July 1st this year and will be 2 years. The total funding is around 1 million euros. And with coordinator as TU Dresden and the 12 partners from 7 countries here. So talking about a partner, I want to emphasize here, we are having all the major players from telecommunications side, that is Ericsson, Nokia, 35 Lab and Nokia, and the 5G Infrastructure Association, that is association as a private part of 5GPP and TU Dresden. From microelectronic side, we have Infineon, AXP, ST as an industry partner, and AENEAS, which is one of the associations and the private board of ECSEL. And again, we have very strong research institutes involved, CELEDI and IMEC. As mentioned before, that 5G is not just about the consumer market, it's also about vertical, about industry. So we also have one representative for the vertical industry, that's Bosch. And then if we look at the future component market or opportunity in Europe, this might be something very interesting for SME community. This is the reason we also have SME community representative Astrolog in the consortium. If you look at the left side, that our project is constructed based on a value chain approach. Of course, what is the exact value chain? There's a lot of different school of thoughts, and from different industry, you have different way of presenting what is value chain. This is just one of, one way presenting it. But the message is that we are having partners that from different layer of different types of value chain. So with this consortium, we have a couple of objectives to achieve. First is to help decrease the Europeans' dependency on other continent from component point of view. So here we are not talking about close ourselves or protectionism, because openness is the strength of Europe. What we are talking about here is ability to act. Next is that we have to involve industry, but we cannot do with microelectronics industry alone or telecommunication industry alone. As already mentioned many times in this conference, that the very important part of our strategy here is collaboration and partner. partnership. So here we bring both industry together and do a concrete strategic roadmap on core technologies. The next element here is community. In order to achieve our goal, we need to have a critical mass and the collaboration between ECS community and network community. Last but not least, in addition to all the industry community, we also need to act. So there's a very strong need to, in the end, to promote our results to stakeholders in both private and public sectors. Especially, we see there's a possibility for develop one or more European champions in the domain. From technical point of view, let's start with computing and storage. As also mentioned in the whole conference that we want an advanced process. I want to really make this very clear that not just health, not just automotive, not just artificial intelligence, connectivity, 5G and 6G, we also need processors. This is very important for our industry. It will be, if we evolve from 5G to 6G in the future, it will be intelligence everywhere in base station, in edge, in cloud, in the device. So this is very critical for us, and this is, as well organized, recognize that this is something we are missing, but a very critical competence. The next dimension will be communications and sensing. This is something Europe is traditionally very strong analog design. If we're looking at the evolution towards 6G, it will push towards millimeter wave and terahertz. Okay, depends on your definition what is terahertz. Anyway, we will go to higher frequency. So it will open the door for combined communication with sensing, localization, imaging. So this could be even more opportunities for European industry. The last but not least is the peripheral. So again, 5G from 5G to 6G to the future, it's not about consumer markets anymore. It is about also industry. It is about the ability to massively connection heterogeneous device, not just mobile phone, IoT device, sensors, and all the novel devices that could be used in vertical. So it is very important to look at the value chain as a whole to have a complete strategy. Above all these three technical domains, we need to also bear in mind that we need to have a sustainable future, a green future, as already discussed in the morning. This is Europe needs to have a neutral, climate neutral by 2050. So it's very, very important to develop the system with energy efficiency in mind. Another dimension is, of course, security. We must have security in the design towards 6G. So actually, these two dimensions, security and the energy efficiency, are also the domains that Europe is quite good at. We can see this could be an opportunity for our industry. So in this project, we're trying to bring a top-down method. So first of all, we understand what is 6G, and then based on its application to comprise a vision and a strategy. From that, we define what would be the important technical domains and investment requirements. Then we derive the corresponding core technology road mapping and the guideline. I want to emphasize here, this is, even though it is presented here as step 1, 2, 3, 4, but the process will not be just linear. It will be an iterative process. For example, today, what we are going to present to you, it will be the first iteration, the results of first iteration, and the way we would like to interact and receive feedbacks from you or the communities. And here I would emphasize here one dimension in our project is the expert groups. And so with these three domains, so we have already quite many experts recruited. Thank you for that. And then we will have next round in spring. So this is a timeline of this project that you will see. It is posted by 4 major events, 2 local located ways, major events of ECS Community, and 2 major events with network community. So the target is that in the end of this project, we will have a common vision, roadmap, community, everything will come together. So as the last slide, I want to really take this opportunity to thank all the partners and all the experts and all the community and the European Commission for your support to us, so that we can embark on this exciting journey with you in the middle of pandemic, and we look forward to the collaboration. So for that, I conclude my presentation.
Thank you very much, Yanning, for your presentation. And now we are lucky to have a special guest from the European Commission. Mario Sila is a program officer in the unit Future Connectivity Systems of the European Commission. The unit is responsible for the policy and strategic developments of 5G in Europe and for the definition and implementation of the EU-funded research and innovation in future networks towards 6G. Before joining the Commission, Mario held various positions in the private and public telecommunications sectors. He holds a Master of Science in Electromechanical Engineering from the University Libre de Bruxelles in Belgium. Mario, the floor is yours.
Thank you, Jack, and good afternoon to everyone. It's my pleasure to be as a speaker in this workshop. I would like to quickly introduce to you the context around the Connect project and around our vision from the Commission on why this strategic autonomy and why the work that will be done here by the project is so important. So very quickly, some issue with my slide. So Europe strategic autonomy, what it is about. So it is about reducing dependence on other things, on others for things we need the most. So it is one of the extracts that we can find on our policy communication. So this is the very broad shape of what we mean by strategic autonomy. On other policy communication or documents published, we also link this strategic autonomy with technological sovereignty, and also with the fact that digital infrastructure are very important and are key into the society. Also, another things I wanted to highlight is that we have engaged and we have clearly announced that we will support the development of key enabling technologies. And in the context of this conference and this workshop, of course, the electronic component and system area is fully part of that. Since the beginning of this mandate, now more than one year ago already, we have put digital at the very highest priority, one of the 6 highest priority, and after that, on the different communication around our strategy for the digital future, our industrial strategy. The technological sovereignty has been mentioned many times, also of course put in a kind of twin relation with the green, so what we call the twin transition, the green and digital transition, even more put on the focus by the COVID now. Something important also to mention for today's workshop and for this project is that the new industrial strategy of the Commission clearly mentions 6G and future network as an area where we need to do something. So what will we do? This is our this is one of the instruments, not the only one, to address this high-level political target. So we're talking about digital partnership for the next framework program. We have proposed some of them. The 2 most important, of course, for today discussion is smart network and services on networking towards 6G and all the related aspects, and KDT on all the component and hardware aspects. So very quickly, you have heard a lot about this partnership, but on smart network and services, something to mention is that we want to address the full value chain. We want to extend the scope from the pure networking, because today networking is encompassing, or the cloud is encompassing as a direct link also with other software approach. It must include security, it must include energy efficiency, of course. These are kind of horizontal for all the ICT, but still. And here, what is important for us and for today's discussion here is about this, down on my slide, the link with the devices, the link with the hardware, what we call new opportunities for enabling technologies. So this is why the link with the ECS community is important, and why we think technology sovereignty is key. If I don't present it here, but the strategic research and innovation agenda developed by the community from the telecommunication by Network 2020 is already addressing this specific part on the enabling technology. Then when we look on the other side from the ECS community, you have maybe followed this morning presentation by the association from ECSEL. They are developing the strategic research and innovation agenda for 2021, but this SRIA is addressing the long-term research also for the 10 years to come. And on this, at least on the draft currently, but clearly there is a section on connectivity, which addresses 6G, which addresses also the technology sovereignty. So all these are in input and the starting point, I would say, from the work that the project is doing. Why this is important for us? This is why we think I see that my time is already over, but I will go quick. Our vision is to have, of course, leadership in component as a key aspect for strategic autonomy, especially in our connectivity domain. This is clear. We think that we have strong know-how in Europe, strong industrial leadership in some area, but it's also global momentum worldwide, meaning that many regions of the world have started and have put a lot of money on this aspect. So we want to involve the two community. We want to be sure that the component part is addressed on the 6G, and we want to have a top-down approach. This is what was the boundaries, or at least the scope we wanted to put into the Connock project. And so that's why we have started this initiative as a bridge between the current situation and then the partnership that are coming in more or less in 2021. So very quickly, these are the Connock expected outcome. Yannick just presented them to you, but of course they will implement different steps to reach this European roadmap and to improve our strategy on the long term to being able to address this strategic autonomy. I will not go into these details, of course, but these are the type of idea that maybe you can discuss this afternoon and for which we are interested. This is just some of them that I have put on the slide. Of course, it's absolutely not exhaustive list, but it's just to start thinking a bit about this. So to conclude quickly, for us, Commission, it's extremely important to address the field of strategic autonomy. You have understood it from the highest political level, especially on connectivity system. We think the component part is key and is very important. That's why we have started this initiative, and we really count on the two community to work together and on your input to be sure that we can solve this, or at least we can on the long term address the technological sovereignty. Thank you very much. And this is finishing my presentation.
Thank you very much, Mario, for your speech and for taking the time to participate in our Connock workshop today. So I just would like to remind everyone in the audience that you can use the chat box to put your questions. Now we are going to move to the first session of the workshop. Work package 2 in Connock is about defining the strategy, vision, and requirements for the core hardware technologies that will allow to build a European technological sovereignty in 5G and beyond. Bjorn Ekelund will present an overview of the initial insights and conclusions of the experts working on this issue, as well as some opportunities and challenges that have already been identified. Bjorn is responsible for antenna, electronics and electromagnetic radiation research in the Ericsson Group. He has held leading roles in both businesses and technology in the wireless and microelectronics sector for over 30 years. Besides his role at Ericsson, he is also a board member in several companies and organizations and an advisor to industry associations and government agencies. Bjorn Ekelund holds a master's and a doctoral degree from Lund University. Bjorn, please proceed with your presentation.
Thank you. It's a pleasure to be here. Let me just get my screen up. I think this is, so I'm going to give you an introduction to the preliminary observations and ideas that have been created in this early phase of the project. And I'm going to take a look at the position of the European microelectronics industry today, a brief 2030 outlook, including some comments on 6G, and then looking at a bit deeper into the situation for the European microelectronics industry and some suggested actions going forward. If we look at the European microelectronics industry of today, as we heard earlier by Dr. Janning, Europe has a weak position. We have when it comes to the proportion compared to our GDP, our share of the world's GDP, our position in electronic components, electronic boards, and electronic equipment is fairly weak. And this is a development that's been going on for quite a while. It started really with going back over 10 years ago, when European manufacturers started losing the market-leading volumes that they used to have, and to keep profitability and to survive, basically, the focus shifted to differentiated technologies like advanced material-based 3-5 materials by CMOS, GaN, gallium arsenide, indium phosphide, etc. And that basically meant that Europe dropped out of the Moore's law race, and very much of the manufacturing moved east. Now, what this also meant was that Europe lost the fabless players sector. In other areas, other geographies like the US, the loss of manufacturing, of advanced semiconductor manufacturing has been replaced by the emergence of fabless players. Companies designing very advanced SoC and then relying on manufacturing at other places. That has not happened in Europe. And now when we see product differentiation moving into software and microelectronics, as I will go into more detail later about, this is really a threat to the European industry as a whole. There is now, with this wave of digitalization we see in the world for both organizations and products, there is a very strong connection between industrial strength and the microelectronic strength. I think this is very much recognized by China, for instance, who is doing massive investments into this to secure the future competitiveness, not just for the telecom sector, but for all sectors. So why is now 5G so important? It's really because, first of all, digital infrastructure is really critical to society and must be trusted. We heard that previous speakers talk about this. The digital infrastructure is the spine of modern society and enterprise. And we also see products digitalize. And this is not just sort of mobile phones. It can be anything. Everything from lawn mowers to furniture becomes intelligent and connected and sensing. And if we don't have these technologies, if we don't have this competence pool and the manufacturers and the suppliers in Europe doing these things, we may end up becoming passive users of others' technology instead of adding true value. So this means that these technologies, the 5G and its related technologies, are really value enablers for all European industrial sectors. We looked in our work. We have dived into two value chain a little bit deeper, and they are really key to Europe, but they are not the only ones. The first one is the telecom value chain, and that is fairly obvious talking about 5G, and that is a European strength. But unfortunately, the supply chain has moved out of Europe. So we have strong players in the telecom space in Europe, but their entire supply base, almost their entire supply base, is non-European. And that, of course, makes them vulnerable to geopolitical challenges, for instance. And it's also so that the proportional relevance of the strength of Europe, I mean, advanced radio circuits, advanced analog technologies, the proportion of that relevance is falling in the products as the telecom products become more and more digital, more and more software. Of course, advanced radio circuitry, advanced antenna solutions, advanced analog circuitry still represents a large value, but its share of the value in the modern digital infrastructure is falling. There's also a strong political drive for open network architectures, particularly from the US government. And the risk with this, and the strategy is very sort of conscious from the US government, because going this way will play straight into the arms of the big cloud players, and they are all based in the US with a few exceptions. The other value chain we looked into is the automotive value chain. This is really Europe's flagship industry sector, employing over 15 million people, including suppliers and the entire value chain. Now, that's going through a very dramatic change. We have electrification, we have software. We see today that the value share of electronics in a modern car is up to 30%. So this means that the value chain that has been largely European in the vehicles segment is now also moving out of Europe. And that is, of course, a threat to the European car industry's sovereignty. And it's increasingly clear that there is a really strong symbiosis between the semiconductor sector and the automotive sector. And we also see car manufacturers starting to design their own chips, something that was unthinkable only a few years ago. This also drives very drastic changes in competence requirements for the automotive players, with much stronger emphasis on software and electronics. I think this picture from the Efecs conference 2 years ago is very telling. I added my own little graphics to the left here. We can see that at the bottom of this value chain you have the chips, and then going further up you have the electronic boards, the subsystems, the products, and so on. This is really a situation a couple of years ago, maybe 5 or 10 years ago, where the microelectronic circuits at the bottom, they represented a fairly small share of the value, and very much value was added in the phase of developing the subsystems and the boards. And Europe has been very successful in this. However, what is happening now with more and more advanced semiconductor technology is that the share of the value captured by the microelectronics grows upwards, leaving less and less room for the European players to differentiate, to innovate, and to, of course, make a profit, basically. So there is a big risk that, as I said before, that European manufacturers, European industrial players ends up being passive users of others' innovations. And we want innovation to be European. So moving on, the 2030 outlook, I mean, what is 6G? I will not spend a lot of time on diving into exactly what 6G is, because, well, first of all, nobody really knows. But secondly, I think this is something that we can also discuss in the panel. But 6G, I think there is a general consensus on a number of characteristics of 6G, and I've listed a few of them. The first one is really non-limiting connectivity. We have affordable, ubiquitous connectivity with extreme performance. The connectivity itself is no longer a limitation. The Internet of Senses means that we are now not only conveying traditional signals like audio or video, but also other senses, maybe even taste and smell will be transported over the 6G network. This, of course, relies on the development of new sensor technology, but that is in the pipeline. We have the Internet of Robotics, the Internet and the 6G network controlling physically moving objects safely and securely. We have the programmable physical and biological world where things will be intelligent and connected and programmable, containing software. We have a network compute fabric, the amalgamation of a communications network with a distributed data center, where you have computational and storage resources spread over entire geographies. We have the sustainability challenges that 6G will be able to address. I think there is a common understanding that the answer to the challenges today when it comes to urbanization or pollution or energy consumption, they're all in the digital domain. And finally, we have the important, perhaps the most important factor of all, and that the systems are trustworthy, that they support the correct, the necessary privacy, integrity, and of course dependability that is required to work in the modern world. So then, finally, looking at the state of European and microelectronics, the strengths that we have identified is that we have a leading position in cellular infrastructure. We have some major players, and we have a large market share globally. Europe has that. Also some strong integrated device manufacturers, many of them being represented here at the workshop today, who offer connectivity solutions and the derivative technologies that I mentioned before, often based on advanced materials, where Europe really has a strong position. We also have a leading position in industrial connectivity, at least the one today, which is not based on 5G or 6G. And we have a strong microcontroller ecosystem as well, and that is well suited for IoT devices. Now, however, we have a complete absence of consumer cellular connectivity products in Europe. That market has really moved east and west. Or I should say the players have moved east and west. We also have a lacking ability to develop really advanced CPUs and AI accelerators. And together with that, we have a lacking ability in doing advanced SoC design, the fabless ecosystem that I mentioned earlier. So the suggested actions that we have so far drafted is that when it comes to manufacturing, we believe it's important to maintain the effort on the derivative technologies. That's really a strong point for Europe. And maybe over time also more advanced CMOS manufacturing. Advanced CMOS manufacturing is very much an Eastern Asian affair today, but that's not really because of labor cost or anything else. Advanced CMOS manufacturing is very much an investment game with very large capital investments, and geography doesn't play that much role in that actually. But this probably should be a longer term objective, because to make proper use of this, Europe needs to have much stronger abilities in advanced SoC design. When it comes to product development, we believe it's important to invest in activities to move up the value chain. We have a lot of strong positions in Europe today when it comes to various product segments, everything from furniture to consumer goods and heavy machinery. But there's a big opportunity with digitalization to move up the value chain, to move from manufacturing components to manufacturing systems, to move from selling products to selling services and so on. We need to reinforce the CPU and AI accelerator development initiatives in Europe. Today we see that maybe with the exception of ARM, pretty much everything in this space comes from outside of Europe. We are also weak when it comes to cloud technology. Although much of the innovation happens in Europe, the commercialization does not happen in Europe. We also need to invest in making advanced digital ASIC design possible in Europe. And this is not only the capability when it comes to talent and competence, but also CAD tools. Today, the software tools used to do these designs is almost entirely from the US. And then finally, when it comes to research and innovation, we believe that the talent supply is super important. I think I mentioned that a couple of times already. I think, and here the European framework programs are really important. They are a good way to attract and to build talent in Europe. We should also encourage academic collaborations with world-leading institutions. They are means to both improve the training of our own students, but also to attract top research talent into Europe. We should continue the effort that is already ongoing on the derivative technologies I mentioned before. We have a strong position there and we need to keep it. And then finally, as with product development, we need to strengthen our capabilities in digital ASIC design, advanced digital ASIC design. In various sectors, we have the microcontroller, we have the CPU, we have the AI accelerators and other fields. And there are, of course, very strong links to investments for software because hardware does not live in its own. I mean, it always goes together with software. So that concludes my presentation today. Thank you.
Thank you so much, Bjorn, for sharing the initial thoughts and ideas and suggested actions from the Connock project. I would like to remind everyone in the audience that, of course, you can comment or ask questions through the chat box. And I'm sure Bjorn's presentation is already raising a number of questions and comments. So now I would like to give the moderation stick to Yanning Zhu, who will be the moderator for the next panel. And Yanning, I would like to remind you that you have 30 minutes sharp for this panel because we have a constrained agenda today. And to the audience, I want also to remind you that you can follow the hashtag Efecs2020 on the social networks to get all the news about the conference and our workshop. Yanning, up to you.
Okay, so thank you, Jack, again. And so also a reminder on the time. So we are in a very tight schedule, of course. So welcome to everyone. Welcome to the panel session about strategy and vision and requirements. As Bjorn has already given you a glimpse of work that has been done inside the project. And here we will have all the representatives of organizations who are leading the work in the project and elaborate their views to you audiences. So before we start, I would like to first introduce you our panelists one by one. And so I start with telecom side. And first one is Alexandros Kalosilos, who is Executive Director at 5G-IA from Belgium. Then the next you have seen Bjorn Eklund, Corporate Director on Hardware Device and EMF Research and Ericsson from Sweden. So next we have Frank Hoffman, who is Chief Expert on Mobile Communication Systems at Robert Bosch from Germany, and who is also a representative from the vertical in our panel. So next one will be from next week from the microelectronics industry. We have Patrick Cotier, Technique Program Manager at AENEAS from France. Next, Patrick Pipe, Director of Strategic Partnership and NXP from the Netherlands. And Dominic Thomas, Director of R&D Partnership and ST Microelectronics from France. And last, Gerhard Feldmeiss, Vodafone Chair Professor and at TU from Germany, who is also coordinator of the Connect. So before we start the panel, I would also show, in order to for audiences better to interact, I also want to share my screen here. How can I share? Sorry for the delay here. Why I cannot? Okay, maybe do I need to exit from the spotlight? Okay. Okay, it seems it's not working at the moment. This slide for me, apologize for that. So,
Yang, do you want to send me the slides? I can share.
I think others have slides on the next. Okay, I can send you the slides. Yes, maybe we can start with.
Yeah, to start.
Yes,
Maybe
we can start already because as Bjorn has already mentioned that we need to understand what is 6G, or let's say, okay, no one understands 6G, but now we are in a conceptual level, and what compare 5G, what is actually the difference, right? What is the difference that make the special requirements on the microelectronic side? So I would start with this question with Geha Yu. You are the, in network domain, and normally our academia is the one who started the fire. So from your point of view, what would you see that what is the difference?
The difference going forward to 6G, or? Yes?
Yes, compare 5G, what is the difference? 6G, major difference. And how
so
that impacts the component design?
So for me, the big difference is 1G was business mobile telephony. It was a company phone. 2G was the personal mobile phone. 3G was BlackBerry, Nokia communicator, the business smartphone. 4G was the consumer smartphone for everyone. 5G, we're talking about verticals again, so construction industry, agriculture, industry 4.0. Again, meaning non-consumer, but business applications. And 6G is going to be personal mobile robotics. And to enable that, we need to do quite a bit of homework. So just like we went from the business side to the consumer side, we always had to change the air interface. Again, we will need to have to change the air interface here because we need to incorporate radar. So if we look at it right now, 1% of the European population gets 5 gigahertz of spectrum to do radar for free. 99% of the Europe's population has to pay billions of dollars in license fees to get only 1 gigahertz to do jamming all the wireless communication. So we are currently really subsidizing those people that can afford cars with radar in a big time via taking away the money from everyone. So to be very, let's put it in a political fashion that is maybe to overstretch it a bit. So what I think we really need to do is look at this and see how can we embed the functionality for personal mobile robots, meaning radar and spectroscopic sensing and other kind of activities and possibilities, such that we can really have our personal mobile robots doing our wash at home, following us while shopping, doing the yard cleanup work, exoskeleton that we can put on, learn how to do this sports, that sports, be playful, gameful things, so that any age group that we have from birth to when we say goodbye is really supported with personal mobile robots of different kinds. And this is where we really have to look at and see what are the requirements.
Okay, thank you, Gerhard. So next, I want to also ask, after academia, of course, we come to the industry. And so I want to ask Bjorn, in your view, what is the difference between 6G or 5G, or let's say our envisioned 6G compared to 5G, and what could be the new requirements on the component and microelectronics design?
Well, I try to avoid not repeating what Gerhard said because I agree with a lot of it. I think the challenge will be to offer this extreme performance and also new communication means. As I mentioned in the presentation, we will no longer limit ourselves to audio and video and sort of traditional telecommunications means, but also new sensors, everything from smell to holograms will be transported. And of course, this being done in a way where the cost is so low that it can be meaningful and attractive for consumers. So I think driving this extreme performance and also intelligence, I would say, down in price points, that will be a big challenge, and that will need very, very advanced hardware and software to reach this goal. And of course, there will be radio technology and there will be higher frequencies used and so on, but a very large part of the challenge will be in the digital and the software domain.
Yeah, absolutely. I think you made a good point that it's not just about extreme performance and the functions, it's also about the cost. And that will be the key, how far we can go. So next I would then ask also Alex, I understand that from 5G-IA point of view, you have devised this smart networks and partnership proposal.
Yes.
Yes, and so from your point of view, from the 5G-IA point of view, what do you see would be the biggest difference compare 5G to 6G, and what it means for our microelectronics partners?
Yes, thank you, Janine. We have listened already some very good examples of what 6G can bring into our life. I would like not to repeat the same points, but address this from a different perspective. Of course, nobody can say with 100% certainty that 6G is going to be this or that, but still we see some specific trends in terms of what we need essentially in the new networks. For example, we see that the full digitization of the verticals, because 5G has opened the door of the verticals, but in 6G we are going to see a full digitization, will require extensive solution in distributed high-performance computing. We need to move computing resources close to the edge of the network in order, for example, to reduce the expected delay. Or another example is that the 6G networks are going to be quite complex. I mean, even more complex than 5G networks. And 5G networks are already more complex than 4G. We have multiple slices, multiple logical networks on top of the same infrastructure. We have these logical networks competing for specific resources. So we see that AI and machine learning will play a more significant role for the beyond 5G and the 6G networks. Also, we are expecting a tighter interworking of verticals with the end services, I mean, with the network. So security and cybersecurity will play an extremely role. We believe that we see a trend of the evolved networks are increasingly being driven from software, cloud storage, and platform-based services. And this will bring some opportunities, but also some issues that we have to address at the European level.
Okay, thank you, Alex. Gerhard, can you, maybe we can stop share the slides here so we can see the actual speaker. Thank you, Gerhard. So, okay, so thank you, Alex, for sharing your insights here. And so when we talk about the 5G, 6G, very important thing is to talk about the vertical, because this is one of the most important dimension towards digitization. So from Frank, can I ask from your point of view, what's, from vertical point of view, what do you see the new requirements imposed from the 6G, in particular for this automotive industry, as Björn has mentioned, that it is one of the biggest, sector, very important sector for Europe that accounts about 7% of GDP. And when we have more electronics, more computing power needed for the future, is this a threat or opportunity?
Thank you, Janine. I want to open up the scope a little before I come really to the concrete answer here for your question. And as Björn already mentioned, GDP is quite important here in the automotive industry. And we have, I think, a very good overview here, because we are not only as a company in the semiconductor business, but also as a tier one in the automotive sector here. And we see here also some really threatening topics here because of the technical trends we see in the ecosystem. Because on the one side, there are some major trends in the automotive industry, as you can read every day in the newspaper, about autonomous driving and connectivity, electrification, big data analytics, and this really will change quite a lot in the automotive industry. And here, Europe has to be very careful to keep a leading position. And currently we concentrate here in this discussion mainly on 5G connectivity, but I will also come in 6G connectivity, and I will come back to this. And what I think is that the vehicle will be in future kind of ultimate electronic device. It's not only a car anymore, but we will have much more electronics. And a lot of these new technologies we talk about, AI, connectivity, will be part of the vehicle. And this is really also a major change which comes quite fast here. And together with this technology trends, we have also a change in the ecosystem, because in the past we had the semiconductor companies, we had tier ones, and we had the car manufacturer, and this was a very simple structure in the ecosystem. But nowadays what we see is here more connected value chain. We have these big players from the IT world, mainly also from the US, and we have these major players from the Asian pushing for new semiconductor technologies, and often the car manufacturer talks directly with these new tech players, and this means also that the influence of these new players will increase quite a lot here. And coming more in detail about 6G, I think Björn already showed very nicely here some trends, and especially for the automotive industry, I think there are two things which I want to show or to mention here. This first one is the Internet of Robotics, because a vehicle is a kind of robot, and we need this interconnection between vehicles, and that's something we started already several years ago, but nevertheless there is still a long way to go, and we have many ideas how 6G could improve here safety and traffic efficiency and comfort for vehicles. And what's come with the Internet of Robotics along was trustworthiness, because if we talk about safety, then the current systems are not designed for such challenges, because we think in the automotive ecosystem often about functional safety, and that's something completely new and which could be part also of the 6G technologies. Thanks.
Okay, thank you, Frank, for sharing the view here. And I think the message is very clear that what is, from your point of view, what is important in 6G and the vertical. And so next, maybe we can ask also from our microelectronics side that, for example, Patrick Pipe. So what is your view, and especially when we talk about automotive, I think you are very familiar with this area. So what is the view that 6G might change, impose the requirements on the, on the component design, and also from microelectronics point of view. So what other core technologies that needs to be developed in addition to what Bjorn mentioned in his slides, and what is our situation now in the Europe with respect to the value chain?
Okay, thank you, Janning. So I would like to take it from two angles. One is what are the technology requirements specifically, but also what are the cooperation requirements. And I think Frank has already indicated we are changing from the classical value chain towards a value network, where in fact all stakeholders in the network are considered as equal players and are setting up together the requirements of what is really needed. Just to make a parallel with the automotive sector, I think 3 of the current present microelectronics players, they have worldwide top 5 position. In the top 5 of semiconductor sales in automotive, I think we should aim to regain that also for the 6G connectivity domain, because now we are active in a number of niches where we are number 1, but we should play it on a more global scale. And I think therefore it's very important that all stakeholders, from system providers to semiconductor players, work together on in what domains Europe will play a key role in 6G and how to take European sovereignty in the strategic parts of the complete value chain. If I look to the technology requirements, I think the big difference between 5G and 6G is about the fact that 6G is a more distributed architecture. There is more emphasis on the end nodes. And I think there is also an area where we as semiconductor players in Europe are strong in. Low power, for example, requirements are key. But even more important is security, authentication, authorization, which will be key for 6G, and because of this distributed architecture. And I think we should pay a lot of attention how to build further upon the strengths Europe has in this domain, because we have a number of key universities, key research institutes, industrial players who are even setting the standards in this domain. And we should keep this competitive advantage to build a strength in the 6G domain. Of course, in addition, but then we go into a bit more detail, I think a number of strategic technology nodes are important. We should not aim at winning the battle in the more Moore strategy from a European semiconductor point of view. We should win the battle in the design aspects on that, but not in the manufacturing aspects. But we should work on, as Björn already indicated, some specific technology nodes, like silicon, germanium, gallium nitride, etc. So technologies which will be important for 6G.
Okay, thank you, Patrick. So because we have a limited time, we have to move on. Now I want to also ask the same question to Dominic. And also, actually, I want to also ask you about one question for our audiences. It's Gunter, how about so we're asking that, okay, first we want you talk about the same. What do you see the 6G will impose on the requirements for components, and what do you see on the value chain point of view? But we also want to ask you about this question from our audience that regarding power consumption of 5G. So what about the data converter also? Low power processor is one thing, but also new concepts that for which apparently US, like IDMs offer circuits. So please, this is your stage now.
Okay, good afternoon, everyone. I subscribe to a lot of what's been said, especially by the last two speakers. We have to, let's say, concentrate on a number of points that we can ensure. And what will 6G impose? First, the evolution of 5G suddenly will go towards higher frequencies. So we need to, it will impose, let's say, requirements on the semiconductors to reach those frequencies at low power. And that's very important. So Patrick mentioned the SiGe and silicon germanium and the GaN, and you mentioned Yanning the analog to digital converters, and it's very important to have technologies which have sorry, it's a bit technical, low noise factors in order to keep the power low, especially when we go to high frequencies, and we will need phased array antennas with limited power budgets. So here in Europe, we have some strongholds to design those technologies and to be a leader on this market. Then I want to insist on another point. Patrick and others have insisted on security. It's extremely important. It will require also some computing power at the edge, especially if we speak about IoT. There will be a connection from quite many objects, which will need to control what type of data they will send on the network. It has to be, let's say, limited in terms of volume, and also it has to be controlled. And for this, you need to have really developments in microprocessors with embedded non-volatile memories, and you have to be able to do some sort of computing, even artificial intelligence, near the edge of the network. And here there are a lot of avenues to develop in Europe. Okay, I think I will stop here. It's just complementary because a lot has been said, and we should set ourselves goals that we can reach and not maybe dream of something that is clearly out of reach. Thank you.
Okay, thank you. Speak of dreams, so I think always we come back to the question about manufacture, right? So it's clear that Europe should develop what is good at, the RF, the derivative technologies, but as mentioned many times, our telecommunication and many applications, they need digital design. So it is well recognized that we need a fabulous value chain first, but how about manufacture, for example? And it is clear that for the future products of telecommunication, it might need 5 nanometer manufacturing. So what do we think about this? Do we dare to dream about that? So I would ask Patrick Cote from AENEAS. So what is your opinion on this?
Well, so first of all, we in many technologies that you need to master to be able to be independent in 5G and 6G, there are manufacturing capabilities. You know, this morning we had an award to a project, Toronto, who had developed world-leading performances in terms of frequencies, for example, for millimeter wave communications. So there are many parts where we have the manufacturing in Europe, manufacturing capabilities at least. But I guess your question refers more to the very advanced CMOS nodes. And here I would say it's not even a $1 million question. It's a tens of billions dollar questions, because that's what it would take to build a fab like that in Europe, and where we've heard from an experience from ST. That's clearly, I mean, the market is not there for them to justify this kind of investment. And even if the political will and the budget, from public money was there, is that the best way to spend public money? I don't know. But I think here what's really important is to make sure that we have secure and trusted access to the technologies which we are not able to manufacture in Europe. And secure, for example, one way to do that is to have some kind of bargaining power when it comes to make sure that there is no disruption from one region of the world in terms of delivering the technologies that we need. And here we might have some bargaining chips, so to speak, for example, with the fact that we are leading in lithography equipment with ASML. And those regions of the world who maybe have a monopoly on very advanced CMOS nodes, well, on the other hand, they need those equipment. So if, again, there is a political will, so to support this type of, trade agreement or mutual assured destruction, so to speak, if there is no agreement, then this is a way maybe to secure the access. Another way to secure the access is maybe trying to do what the US are doing. I mean, they were able to apparently convince TSMC to invest in the US. So that's very interesting. Can we do this? Can we have the same, political power in Europe to achieve that? That's a way. The other thing is that not only we must be secure to have the supply, but we also must be sure that this is a trusted supply. So in that area, for example, how do we make sure that there are no hardware Trojan horses in the chips that are delivered to us by other regions of the world? I don't have the answer, obviously, but I think this is one of the items that the Connock project has to focus on to make sure that when we cannot afford to have the manufacturing in Europe, we are sure, nevertheless, to have secure and trusted access to the technologies that we need.
And thank you. Okay, and so it seems there's some echo here. And so now we have run out of time for this session. But before that, I want to invite all the panelists to have one sentence to deliver a message to our community here. So for their takeaway from our panel session. So let's start. Maybe Patrick, you were the last one. Maybe you start first. One sentence.
Maybe a sentence is about also opportunity, especially with 6G. I mean, we will need a lot of disruptive innovation. And when it comes to disruptive innovation, the leaders of the previous technology generation are no longer relevant, or at least they don't have a competitive advantage. And we do have lots of, intelligence in Europe and very advanced technologies, very advanced universities, RTOs, to seize maybe these new opportunities. But we need to work now to make sure that these new disruptive technologies are available when we need them for industrialization in 6G.
Okay, thank you. And Dominic, one sentence.
Okay. I think that in 6G, Europe has the opportunity to be a leader in secured, highly intelligent and really power efficient nodes with smart sensors. So we have many technologies to achieve this. We know that 6G will be the generation bringing automation near the people, and so we have to develop those technologies for this, and we can do it.
And so, okay, next, Patrick Pipe.
Okay, thanks. Well, I would say let's have a strong cross-fertilization between the automotive and the connectivity domain in order to build further upon our strengths and extend these strengths into #1 positions.
Okay, now we come back to, thank you, Patrick. And now we come back to the telecommunication side. So, Alex, what would be your message here?
My message would be yes, the race for 6G has started. We know our strengths and our weaknesses. We need a plan, and we need to mobilize the ICT forces in Europe to keep us in the leading position for the 6G networks.
Okay, thank you. Then let's say Björn. So, what's your message?
I think the most important thing for Europe is to make sure that all industrial sectors embrace the power and value of connectivity, intelligence, and software.
Okay, great. So thank you. And then let's say Frank.
I think we have really huge opportunities, but I think also that we have to integrate the verticals industry much more in the design process as we have done in the 5G.
Yes. Okay, Geha, thank you, Frank. Last, Geha, you as a coordinator, what would be your message? One sentence.
One sentence.
Yes.
We are in Europe in an absolute pole position for 6G. Namely, we know how to sell consumer products, we know how to do robotics, and we're great in wireless. So we have 5 years' time to capture this pole position. We're better off than any other area of Europe on the planet globe. Let's grab this opportunity and make it happen.
Okay, thank you. Thank you all the panelists. And so I would like to conclude this session. And for the audiences, sorry, because of limited time, we are not able to address your question and comment one by one, but we will take them all with us and later to our internal discussion. So, and for you know that next year, sorry, I cannot share my screen anymore. So next year, just let you know that we are, by the end of this year, we are going to conclude all the discussion we have here into a deliverable that is by the end of December. Next year, we will publish on our website and open public consultation. So for all of you, if you want to have a say and your feedbacks on our vision, first vision, please join us in this, participate in this public consultation. So to make sure you will not miss this opportunity, please follow us on Twitter and LinkedIn so that you know when this is open. Okay, thank you. So now I give the stage back to Jack. Sorry, it's been a long time.
Thank you very much, Yanning, and all of you for sharing your ideas and views with all of us. And of course, we would need much more time, than we have today to have a more in-depth discussion. But that's a very good start. And as you were highlighting, work is going to continue anyway, and we'll come back at the end of the workshop for those of you who are interested in actually directly contributing and participating. We will have indeed the public consultation of the document, and we will also recruit additional experts. So now we are moving into the next session of our workshop that will discuss the initial views and recommendations from our technical experts on the roadmap. So I would like to introduce you to Patrick Coget, who will be the moderator for that session. Dr. Patrick Coget is Technical Program Manager at AENEAS, an industry association grouping over 300 members of the Electronic Components and Systems Community, in short, ECS. He is the past chair and current vice chair of the ECS Strategic Research and Innovation Agenda. AENEAS' main contribution to Connect is to ensure maximum synergy and knowledge exchange between the work being done within the project and the ECS community. Prior to joining AENEAS, Patrick worked in various management positions in ST Microelectronics. He was in charge of innovation, external research for the embedded solutions sector, and in that position, represented ST in the management committee of the International Technology Roadmap for Semiconductors for 10 years, spearheading the introduction of the more than more trend in that roadmap. Patrick, the floor is yours.
Okay, thank you, Jacques, for this very nice presentation. I don't know if you can see my screen now. I hope so.
Yes.
Yes. So this second part of our Connect workshop will be now focused around the work of the 3 expert groups, which Yanning has been introducing earlier. So we will start by having 3 very short introductions of those expert groups by the chairs. So those expert group: computing and storage core technologies, communication and sensing core technologies, and peripheral core technologies for future networks. And after those short introductions, we will have time for a question and answer session. And for that, I would like to invite you to ask your questions via chat. So for those of you who have not assisted to the whole effect, so maybe you are not yet familiar to how to do that. If you are in a full screen mode, then exit the full screen mode. Click on the upper bar on the VFair window where you see that it's written, you know, question and answer, access question and answer, and from there you will be able to enter your questions. So while we are listening to the expert group chairs, please don't ask to start asking questions so that we can then relay them to during the Q&A session. And with that, I would like to introduce the first speaker, so Professor Gerhard Fettweis, who earned a PhD from the University of Aachen. Then he made a postdoc at IBM Research San Jose, then joined TCSI based in Berkeley. And since 1994, he's a Vodafone Chair Professor at TU Dresden. He also, since 2018, heads the Barkhausen Institute, also in Dresden. He researches wireless transmission chip design and coordinates the 5G Lab Germany. And he's also a serial entrepreneur because he has spun out 18 startups, no less, and is member of 2 German academies, the Academy of Science and the Academy of Engineering. So with that, please, Professor Fettweis, the floor is yours.
Perfect. Can you hear me? I hope so. Yes. So welcome everybody. I just want to quickly storm through CoreNext's EG1, the expert group 1 on computing and storage. So what is it if we look at modern chips and in terms of computing and storage? We have multiple different cores. They are defined by their instruction set architecture, ISA it is called. And these basically we take and build multiprocessor system on chips out of them. And finally, this multiprocessor system and chip is not just sitting there on its own, but it has an operating system such that it can interface with the software running on top. So we have system software, we have task software for the individual task running on the different cores. And this whole thing needs to be orchestrated. So if we talk about the future of electronics in terms of computing and storage for 5G, 6G and beyond for Europeans industry, we really have to look at this complete stack. And that's why the expert group 1 is looking at this complete stack. So basically we can subdivide this in 3 main topics: the operating system, multiprocessor system on chip, and the instruction set architecture. And the idea is to check out where are we today in terms of our position and in terms of achieving key performance indicators. You see a whole bunch of them here, such that we can really provide solutions in a way that it is possible for Europeans industry to thrive. On the instruction set architecture, this is the most basic part, obviously. We see that a lot has been happening and Europe's position is or was strong, but after selling off ARM, obviously, the situation is currently very different. And the question is how to address this or not to address this. Is the problem or not? The second topic is multiprocessor system on chip. This is where Europe is very strong. We have many multiprocessor system on chip in embedded solutions in industrial robotics, in cars and whatever all. So the question there is, however, there is no sort of standard way like an instruction set architecture, an ISA, which gives us this kind of interface. So we need to define this. And is that an opportunity for Europe? And how would that look like is the big question mark here. And finally, on the operating system side, again, Europe is very strong. The new microkernel-based operating system ideas come from Europe. So the challenge here is to define the right principles and see how even on such a multiprocessor chip, multiple little operating systems can be instantiated and orchestrated such a way that the host systems can work together. And how are we then, can we defend our position and make sure that we have our value chain being intact? This is the question of working group, expert group 1, and thank you for listening.
Well, thank you, Gerhard, for this very clear introduction to the expert group 1. I would like now to go to the expert group 2. The chair of that expert group is Piet Wambach. And Piet is a fellow at IMEC, Belgium, and is also a part-time professor at the University of Brussels. He's involved in analog, RF, and millimeter wave IC design using advanced CMOS, SiGe, and 3.5 technologies with applications in wireless communication and sensing. And with that, Piet, the floor is yours.
Thank you, Patrick. I hope you can hear me and you can see my slide. So I'm leading the expert group number 2 that focuses on communication and sensing. So with a group of experts, we want to see where we can maintain, strengthen, and ensure the leadership for Europe in this domain, in a world that calls for ever-increasing data rates, not only at the infrastructure side, more subscribers, but also at the device side. And so when you plan 6G, it comes with a lot of challenges. I will be brief here, I go through some of the most important ones. The requirement for increasing data rates will not only be for a connection between wireless devices and the base stations, but also for the wired backbone, the metro. And then further, there's a pressure to decrease latency even below the numbers that 5G targets. Now, in the future, there will be more communication devices than just a bunch of smartphones and computers that compute with the base station. A broad variety of sensors will also communicate, and there will be a huge amount of them. And all this will inevitably require a tremendous computing power. And this whole scenario is only feasible if power efficiency is largely enhanced. Now, AI can help here, but AI at the same time will be omnipresent to make connectivity more efficient and transparent and fluid and more natural. Next, new services, for example, the AI-based ones, and a whole set of new devices will require an efficient interoperability, both at software and hardware level. And needless to say, security is a default requirement here. We're still in the first phase of the Connock project, so we believe that it is appropriate to start with an analysis of the main gaps in our field of communication and sensing. And to make this inventory of gaps, we are defining 4 classes of connectivity areas. So it's first class is data centers. And next we have the wireless infrastructure. So that's the piece in the connectivity that in the connectivity chain that includes antennas and base stations. And then with industrial grade connectivity, we mean connectivity technologies such as low power wide area networks, and then microcontrollers that are needed by industrial applications like industrial IoT, but also health and automotive. And then finally, we have consumer grade connectivity that today is mainly driven by smartphones. To give a glimpse to this gap analysis, you can see here the main players per region in the field of consumer-grade connectivity. So we have the foundry level, we have the chipset level, and we have the OEM level. Now, at the foundry level, we see that US, Korea, Taiwan, and China, they have big players, but Europe, just as Japan, is absent here. And then similar for the providers of chipsets. Europe does not have a Qualcomm, for example. And then at a higher level, Europe does not have an OEM like Apple. Now, is this a problem? And if yes, how big is that problem? And do we need to fill these 3 gaps, all these 3 gaps with European companies? And if not, where do we put our priorities? And suppose you have a few billions to invest, into which hole would you put your money? And what are the criteria to set priorities? Is it jobs, or are there also more strategic considerations needed in case trade wars become more apparent than they are today? So we see a lot of questions, lots of material to discuss. And so therefore, we will work with about 40 experts in a series of workshops to come from a gap analysis to recommendations for a stronger European sovereignty in the domains that we find strategic. And we will do it by raising questions, discussions, on a few key questions. And to avoid that such discussions are limited to the most talkative experts, we work with virtual post-it sessions. And so in this way, we aim for a democratic way to come to our findings and recommendations in this expert group. And this concludes the introduction of expert group 2.
Thank you very much, Pete. I'd like now to turn to expert group 3. But before that, I would like just to remind the audience that there will be a Q&A session afterwards, and so their questions would be very welcome. There are a few coming in, but we can take more, hopefully. So with that, now let me introduce the chairman of the expert group 3. This is Patrick Coupeau. Patrick is a director of strategic partnerships at NXP Semiconductors since 2012. He started his career at IMEC, and in 1996 he started the startup company Coware on hardware-software co-design, which was later acquired by Synopsys, and thereafter he worked at Philips in different positions. He's also a well-seasoned project manager running a project, Secredas on security for autonomous systems, with almost 70 partners from 12 countries throughout Europe. He is chairman of the AENEAS Technical Expert Group since 2018 and member of the ARTEMIS Presidium also since 2018. And he's also a writer, a technical writer, as he has contributed 2 papers in the book on automated driving, edited by Daniel Watzling and Martin Horn. But he's also author of a book, Zest for Opera, Unleash Your Leadership, which is about management. So with that, Patrick, the floor is yours.
Thank you, Patrick, for the kind introduction. Do you see my slides on the screen?
Yes, we do.
Yes.
Okay, thanks. So first of all, I would like to thank my 2 counterparts in Expert Group 3, Jochen Kozesha and Marina Plitsch. They are doing a lot of work together with me, and I think we're really a team making progress in this field. Just as a reminder, where are we situated? And I think Janning has already shown this slide in the initial presentation. So we are Expert Group 3 on peripherals, which is quite a broad domain. So what have we been doing so far? First of all, to get to know each other so that we know which experts, where they're coming from, what are their domains of expertise, and do some brainstorming on what are the topics we would like to cover in our Expert Group 3. We have defined a number of topics, and just to make sure this is not a complete list, this is just a list of topics which came up. What about production sovereignty? What are critical production issues beyond 5G, 6G peripheral components? What about multi-design wafer for high volume split foundry approach? What type of technologies to focus upon in Europe? What to do in terms of edge systems, AI accelerators? Last but not least, also safety, security, and reliability. What does this mean towards the peripheral domain of connectivity? Where do we want to have control and where do we allow dependencies? And as Pete was already saying, where to use the technology and the competence we have as a negotiation with other parties in the world. And last but not least, what areas not to focus upon. What we have been doing is we have defined a number of 4 clusters in which all these previous topics fit. And as stated, the list was not yet complete, but these are now the 4 topics we want to further discuss about. Core process technologies, including also packaging assembly, manufacturing and technology access. So the first is what process technologies. The second topic is how to access it. The third topic is about system and component architectures, including AI approaches. And the fourth topic is on hardware and software co-design and validation. Where do we want to build a strength in new methods and tools, ranging from device to component and system design? So the next steps are that we will now define what are the top three priorities which we would like to discuss, and where we would like, as in expert group 2, build a gap analysis and define where Europe should be focusing upon. And as stated, our motivation is take leadership in the areas we're strong in, don't try to catch up in the areas we have lost. So this concludes my presentation on expert group 3.
Many thanks, Patrick. And I would like now to introduce the, can you see my screen? Yeah, the panelists for this Q&A session. So in addition to the three expert group chairs, which I already introduced, I'm happy to have with me also Didier Belot, who is Vice Chair of Expert Group 2. And Didier works with the CA Leti in Grenoble, France, and he works as a European Programs Coordinator of the Design and Embedded Software Division in charge of the roadmap orientation. He was also involved in a former CSA called NIRED, which was dedicated to European roadmap, and there he was writing the connectivity chapter. He also is a co-leader of the ECS-SRIA connectivity chapter, and also involved in the IRDS Outside System Connectivity Task Group, IRDS standing for International Roadmap for Devices and Systems. His research present interests are in the millimeter wave propagation through plastic, designed by mathematics, terahertz communication, and 3.5 devices over silicon for millimeter wave applications. From that expert group, we also have Frederic Gianizello from STMicroelectronics, who has a PhD degree in electrical engineering from the Joseph Fourier University in France. He has authored and co-authored more than 180 refereed journal and conference technical articles. I should have skipped that, and I'm sorry about it. But Didier Belot is also author or co-author of about 200 publications and 70 patents, which is quite impressive. So back to Dr. Gianizello. He has served on the technical program committee for the IEEE International SOI Conference, and is now currently serving also on technical program committee of IEEE International Solid State Circuit Conference and of the International Electron Devices meeting. And is also a reviewer for several conferences and journals. Frederic Gianizello is working for STMicroelectronics as technical experts, providing support to customers and performing business prospection for RF, millimeter wave, and optical products. To complete the representatives of expert group 2, we also have Mohand Hashush, who received his PhD in material science from Paris 7 University in 1996. He joined Alcatel, now Nokia, in 2000, working on various research projects. From 2015 to 2019, he was managing director of the 3.5 Lab, which is a joint venture between Nokia, Thales, and CEA. And since 2019, he's in charge of hardware strategy within the Nokia Bell Labs and the 3.5 Lab. And finally, for expert group 3, in addition to Patrick Pippe, we have Jochen Kozerscha, who is Senior Director of Funding and Projects Coordination, and as in Infineon, he has been working there for 2.5 years. He has more than 22 years of experience in the field of embedded systems and power electronics. Before he joined Infineon, he was responsible for the coordination of pre-competitive research and research projects within the European Power Electronics Research Network, ECPE, where he was also responsible for roadmap activities in the area of power electronics in aerospace and automotive applications. And he is a technical coordinator, a member of the advisory board of several ECSEL projects in aerospace, power electronics, and semiconductor area, and contribute to several other European projects. So with that, I'd like to start the Q&A session itself. Let's start with the first question, which is directed to expert group 2, so either Peter or one of his colleagues. What are the ideas of your expert group to fulfill these European gaps in the value chain which you just presented?
I can take it, but Frederick or Didier, you are also free to take it. So let me first give you my opinion. So I think in advanced CMOS, there of course our gap is the biggest one, and maybe I can second the one of the possibilities that Patrick you have raised, namely that we could investigate whether a scenario that the United States is now setting up with TSMC, whether that could make sense and whether it is affordable. But yeah, a deep market study has to be done. But yeah, more important, I think we have to play our current strong cards on the other technologies, because 6G, it is not only on about going above 100 gigahertz, but it will be a strong component there, and there we see that CMOS is really running out of steam. For 28 gigahertz, several players they say, well, yeah, CMOS can do it thanks to the fact that you use beamforming, and the transmit power per PA is still not outrageous, and CMOS can do that. But above 100 gigahertz, it is a different story, and there comes the chance of other non-CMOS technologies where Europe has already a good track record. And then heterogeneous integration is still something that has not been touched upon that much during today's workshop. So we have, for example, we have Leti and IMEC both strong in 3D integration, and exploiting these capabilities. I think it will also be key in 6G.
Okay.
Yes, to complete this, we can say that if we speak about the heterogeneous integration, we are strong in the institute, in the academic, but we have not an example of a strong company who can do this 3G integration up to millimeter wave or up to hundreds of gigahertz in Europe. So that means that we have the basis to do that, and we need to transform this basis in an industrial reality.
Okay, thank you, both Pete and Didier. Maybe another question from the audience. So Europe is a big consumer of mobile radio advanced CMOS and microelectronics. And in Europe, a lot of chip design work is done for this market. Why don't we animate overseas microelectronics producers to establish part of their production in Europe? Yeah, I guess that's It's more a comment than a question. This way we would rebuild the ecosystem for more advanced CMOS microelectronics in Europe. The US and China are doing exactly this with our automotive industry. So yes, I think this actually is not really a question, but more supporting Pete what you were saying. Mm-hmm. Okay. Now for a real question. 5G is still a long road forward before 6G. Do you foresee areas where Europe may still develop a role besides the one pushed by Ericsson and Nokia? So here I would say maybe Mohand as as the industrialist can answer, or maybe Gerhard also as let's say the general project leader of Connock can answer.
I can start. Can you hear me?
Yeah.
So in my view, for the 5G, as already mentioned, it is relying on key hardware technologies, in particular analog and digital, the mix of both of them. Some part of these technologies are already established in Europe. In my view, there is still some key areas where we could play a role. One of them is the introduction of automation and the digitalization of some of the radio part, but also on some of the core network parts. And for that, I think it will be a combination of let's say, artificial intelligence core processors that will be developed in the future, and for which I think there is a key expertise in Europe, in particular the software, let's say, houses and knowledge that we could develop. And for that, I think in terms of patent, in terms of standardization, and also in terms of fabrication, because we could have also some dedicated design. And I think Europe could play a role not only on the fabrication part, but also on the specification, because obviously the digital automation and the verticals will imply beyond the classical, let's say, industries like telecom, but also all the verticals, including cars, health, etc., where Europe have also key leaders. In addition, maybe I will not spend more time. In addition, I think we need also to think in these technologies beyond the radio part and the digital part. There is also the transport part. And the transport part is usually made with optical. And maybe many people don't know, but in optical technologies, many of the fabrication are made in Europe. So for that, we need also to support those technologies to stay as a leader in these technologies, in particular when addressing the next challenges for the many terabytes per second that will be, let's say, requested by the cloud services in the future.
Yeah, from my side, maybe just quickly. What I wanted to say is, I think in Europe, I see no issue filling any single gap. So it is not that we don't have the capability to fill gaps. The only gap that could be is if we want to start 5 nanometer manufacturing. That will take some time, but even that could be decided and filled in the next 5 years. The good news on that side, however, is there's a little bit of checks and balances available. So I'm not talking against the Eurofoundry, don't get me wrong, but at least we don't have to rely on one single region alone. We can rely on Taiwan versus South Korea versus the US for the manufacturing. So there is some diversity there in terms of access and some reliability. So But on the other hand, I do truly believe that we have now a unique window of opportunity of 5 years to capture our pole position and really invest in the holes that we have, because the expertise is there, not necessarily in terms of products and available systems, but the expertise in the heads is there. So if we really focus on that, we can make it happen. Patrick, you're muted.
Thank you, Gerhard. Yeah, another question again, I think directed to you, is about one participant is wondering whether neural network, analog neural network, could also be part of the solution, and how Europe would be positioned with that. Any comment on that one?
Who should comment?
Yeah, Gerhard, can you comment, or somebody else?
On the power side.
I thought more on the computing side, maybe.
Yeah. So I mean, on the computing side, obviously, so what we have is a situation that we do not have the chip know-how. We have the multiprocessor system on chip know-how, but not the computing know-how in such a big fashion that one could say we can build our own sort of computing hardware company as quickly as we would like to. So this is obviously an area that one could also start thinking of in terms of saying, would we want to, as a European Union, also start setting up expertise in computing? What I do see is a lot of activity in supercomputing in Europe, and I'm a little bit worried about that, because my experience and look in being in the technology area now for so many decades is that typically new ideas and new architectures come, just like shown by Clay Christensen in the Innovator's Dilemma theory. They come from the bottom, just like ARM started out with the Apple Newton. That's how it started out, its success, and then moved into mainframe machines of today and standard computers of today. We have to see the same thing happen here again. So if we have an initiative there, I would rather see it from the bottom moving up into this kind of computing situation, because top-down has not been known to be a success.
Okay, thank you, Gerhard. Yet another question from the audience. In your opinion, does NVIDIA's acquisition of ARM impact the European technology sovereignty in 5G, 6G, especially looking at chip design, IP, and edge computing? So who would like to answer that one?
I can give a first answer, and then if other people want to add on, that's possible. Indeed, this is not a preferred scenario, I would say. On the other hand, you cannot predict whatever happens in the world. We should pay attention to what the US, China, other continents are doing in this field. I want to give some counterexample. I think we also have situations where European companies have acquired companies from other continents, and more in particular our company, NXP, we have merged with Freescale a couple of years ago. So this was the inverse situation. But nevertheless, it is important that we keep European key strengths and key technologies in Europe, and definitely we want in 5G, 6G developments to make sure that we have the necessary knowledge in Europe on this.
Thank you. Patrick, any other comment on this acquisition of ARM by NVIDIA?
Maybe from my side, Jochen Köstischer. We heard about that the EPoSS are very well on the market. NVIDIA is a very big player in this area, but maybe we should also pay attention. It's not all about high performance computing in this area, because for sure we have special needs in this area of communications. We need to route signals and instead to have just a number crunch approach. So it's more or less a different application, and different architectures are needed to fulfill the needs we're talking about for the future beyond 6G, beyond 5G and 6G.
And we also have strong European players in these fields. For example, if you look like Colray, which is a French company, they are also a very strong player in this field. So we still have competencies in Europe.
Okay, thank you very much. Maybe a last question to all the expert groups. Maybe one sentence. Because here we have, you know, I'm happy to say that we have a lot of audience, about 100 people last time I checked. So, and one of the next steps is that we will be, as Yannick mentioned, calling maybe for new experts to reinforce the current competencies of your expert groups. So for each of you, what would be the places where you would need to reinforce the competencies of your expert groups? So one quick sentence from each of the three expert groups, and with that we will probably close this Q&A session. Starting maybe with Gerhard. Do you see any need for additional experts in your group, and in which case, which profile are you looking for?
Yes, great that you mentioned that. So the idea of the expert group, one is we are covering the different areas of expertise from all kinds of different places in Europe, obviously, and we're trying to generate the understanding that I gave you. And what we will be looking for in the first half of next year is we will have an open call for additional experts on the three topics that I mentioned. So on the processing and the memory subsystems, from the hardware point of view, from the multiprocessor point of view, all the way to the operating system point of view. And so there will be an open call. We will post it on the web. You will be able to send in your short bio, your short CV, and so that we can then pan out, because the idea is that the current expert group is a dozen or 15 people, and we would like to become bigger, not now, because first it is about capturing the basis, but starting next year. And for this, we will be looking for 30 plus additional experts that are qualified. So I will be calling out for that and looking forward for anybody towards anybody that wants to participate.
Okay, thank you very much, Gerhard. Pete, same question for you.
Well, I think our expert group is mostly filled with hardware people, I would say, and a domain that should be fully exploited, and that could be done, of course, in collaboration with EG1, is the usage of AI in radios, and so there we are still lacking some expertise, and this will be an increasingly important area.
Perhaps just one other point, Pete. From hardware side, perhaps we are a little bit weak regarding optical. So that's perhaps one field where we will be missing one or two people, because I agree with the previous comment from Morand. Optical still remains a very key topic for Europe. So that's the thing we have to take care.
Okay, thank you. And for expert group 3, that's Jochen, I believe, who is going to answer. So Jochen.
Yeah, I try to be very fast as we have to conclude. So from the expert group 3, we see both areas. We're looking for power in the area of transmission, and but also we need to go for energy efficiency, because it seems to be very necessary for this, and also all the power area inside. It's a very necessary topic we need to take a look on. But we will work and clearly invite additional experts to fulfill the needs. So also from our side, we're in a good shape. Thank you.
Patrick, you're on mute.
Patrick, you are muted. I think we should conclude the panel now.
I was going to conclude. So just reminding the next steps here in the expert group. So there will be a submission of a first report of the expert groups, and then this open public recruitment that we have just been discussing. But again, I'd like to thank all the experts who joined us and all the people who asked questions. And with that, I leave the final concluding word to Jacques, who is very impatient about that.
Thank you very much, Patrick and all, for this very interesting session. I'm afraid we are already coming to the end of this Connect workshop, and I have the challenging duty of coming up with some kind of conclusion, although this is obviously only the beginning of the road for all of us in this ambitious objective that we have set for Europe. So, I mean, drawing conclusions on such a rich discussion is extremely difficult. So I will just come up with 2 or 3 maybe key things that I will remember from this workshop. First one maybe is that European technological sovereignty is not protectionism. It is the ability to act. I think this is very true for Europe. And then about the strength that we may have in Europe, like digital infrastructure is critical to society and must be trusted. And we are in Europe strong in security. And then the third and last thing is that the race for 6G has already started. And we are well positioned in Europe, but as long as we can work on those disruptive innovations that will lead us to 6G. So with this, I would like to thank very much all the participants. Oops, I'm sorry. I'm just trying to share the final slide. Here it is. So I would like to thank all the speakers and moreover all the participants in the Connect workshop. And as was already mentioned, I remind you that we are going to open a call for recruiting more experts to contribute. So if you are interested, please go to the Connect website, register to be informed about the latest news. And you may also follow us on social media. We have a Twitter account and a LinkedIn account, and all is indicated here on the screen. Then I also want to mention before completing this workshop that we are currently planning to have another Connect workshop at the EUCNC and 6G Summit that is scheduled currently from 8th to 11th of June 2021. If, of course, the health context allows, we will meet ourselves in Porto, in Portugal. Otherwise, I guess we will meet again online. So with this, thanks to everybody for participation and enjoy the rest of your afternoon. Thank you very much again and see you soon. Bye-bye.
Thank you. Bye-bye.
Bye, everybody.
Thank you. Bye, everyone.
Thank you very much and bye.
Thank you. Bye-bye.
Thanks. Bye.
Bye. Bye-bye.